Hello, hi, namaskar everyone. I Dipendra welcome you all in this one short video of the chapter Straight Lines. With straight lines, we are entering into the world of coordinate geometry, the section which is highly loved by IT JEE aspirants because this is where you need to learn simple formulae, apply decent logic and get the result. This is how easy and interesting this is, this entire coordinate geometry. And in this one single video of these straight lines, we'll cover everything related to this particular chapter. Last year, JEE has asked 20 questions from it, and in this video, we'll cover all the concepts, all the theorems, all the formulae, and a lot of previous year's questions to strengthen your learnings. Don't forget that this is all is provided to you at absolutely no cost. Along with this one short video, we are also giving you these handwritten notes for your revision. And along with this, DPPs are also provided to you at absolutely no cost for your practice in the real-time environment. And you can access all of this by clicking on the link given in the description. In the description, there is a link provided through which you will be redirected to our PW app. PW app is an amazing platform from where millions of students are already preparing for different competitive exams and getting the desired results. So with that, let's get started and see what is there in this particular chapter. So we'll start our discussion with coordinate geometry. We'll understand what is Cartesian system, and then through points and different understandings of geometry with coordinate geometry, we'll gradually move towards straight lines. So we'll start with coordinate system, Cartesian system basically. Then we'll talk about straight lines, its different forms, its derived forms. And then of course, we'll talk about some other concepts as well. For example, angle between two lines. For example, position of a point with respect to a line. Then we of course derive the relationship between a point and a line. How do we relate them? And how are questions formed on merging these two concepts basically. We'll talk about lines being concurrent as well. This is something we have discussed in determinants as well. So I hope you must have remembered it. And of course, then we'll keep talking about locus as well in between meanwhile during this entire discussion. So this is the broader categorization of what all will be covering in this particular one shot. And of course, through this straight lines understanding, you will have a great clarity of this particular chapter and its concepts. Let's get started without any delay, right? So first of all, let's understand what is this Cartesian system, or how do you understand coordinate axis? It's a very basic thing, students, here. First of all, you need to understand that if I have two straight lines which are perpendicular, one of them is horizontal and other one is vertical, and they are having this 90-degree inclination with respect to each other, and they are intersecting at a point which we are calling the origin. So this origin is called 0, 0, and we all know this will be 1, 0, 2, 0, 3, 0, and 4, 0 on the x-axis. On the negative x-axis, it will be minus 1, 0, minus 2, 0, minus 3, 0, and so on. Similarly, the same classification or the same categorization is done on the y-axis as well. So here it will be 0, 1, 0, 2, 0, 3, 0, 4, 0, minus 1, 0, minus 2, and something like that. This is how points are plotted on x-axis and y-axis respectively. Now here, what you need to understand is that let's say there is a point anywhere on this plane. Let's say there is a point. So if I were to define this point more uniquely, what all parameters should I bring here into the picture? So let's say this point is given by 2, 3. Now what does this mean? 2, 3, let's say there is a point. So first of all, remember, if a point is defined as 2, 3, then this 2 is called here the abscissa and 3 is called the ordinate. I'm really sorry. This 2 is your abscissa and 3 is your ordinate. I hope there is no confusion on that. Now, what you all need to understand is here, with this 2, 3, that from 2, 3, if I am dropping a perpendicular here on the x-axis, and from 2, 3, if I am dropping a perpendicular on the y-axis. This, of course, 2 is your x coordinate, 3 is your y coordinate. From this 2, 3, if I am dropping a perpendicular, then this particular distance is called 3, and this particular distance is called 2. Why? Because this point over here is going to be nothing but 2, 0, and this point over here is going to be nothing but 0, 3. So always remember, whichever point you plot in the first quadrant is going to be having its x coordinate and y coordinate to be positive. But if I talk about any point in the second quadrant, can you make some comment on it? Yes. If there is a point in the second quadrant, let's say any point, if I take any point, let's say I take minus 3, 1. So I hope you realize in second quadrant, the x coordinate of any point will be negative and the y coordinate will be positive. Similarly, when you talk about any point lying in the third quadrant, I hope you're realizing in third quadrant, if you look at any point, that will have its x and y coordinate both to be negative. Why? Because x is also negative, y is also negative. And in the fourth quadrant, x remains positive, but y becomes negative. Do you understand that? I hope this makes complete sense. Oblique system is also there, but as of now, let us restrict our discussion to rectangular system, and that is what we'll be dealing with in this particular chapter. So I hope so far the very basic details which you all must already be aware of is being revised. Now let us move to the next part. What is that? So here we have already discussed this particular part, that there is a point P which is having x comma y is its coordinates, ordinate and abscissa of course, and here x and y, I hope you are understanding, are nothing but what? What is x? X is the perpendicular distance. If I talk about mod x, so mod x here is the perpendicular distance of this point from the y-axis, and mod y is the perpendicular distance of this point from the x-axis. That's exactly how you define the x and y coordinates. Now, moving ahead, let's get more clarity. Let's see what else do we have. So of course, x coordinate, as we have already discussed, is called the abscissa, and y coordinate in a different terminology is said to be the ordinate. I hope you'll remember it. But of course, usually or conventionally or traditionally or mostly, we write them or tell them or call them x coordinate and y coordinate. But in some questions, you may see them written as abscissa and ordinate. So for example, if I say that here there is a point 2 comma 3. So some books or some questions or ITG sometimes call it 2. This 2 is said to be the abscissa of this point, and this 3 is said to be the ordinate of this point. I hope there is no confusion on that. Moving ahead towards the next part here, these are some generalizations. Always remember, if you take any point, then if it lies on the x-axis, then its ordinate is always going to be 0. It's y coordinate basically. But if you take any point on the y-axis and its abscissa, which means its x coordinate, is always going to be 0. I hope you remember that origin where x and y-axis intersect will have its coordinate as 0, 0. Similarly, that if this is something, if I were to explain, this is something we have already understood twice at least, so I need not explain this particular part again, that a point is taken on anywhere on the Cartesian plane, and if I take its perpendicular distance from x-axis, then it will be its y coordinate without sign if I just take its magnitude only, and if I take its perpendicular distance from y-axis, it will be the x coordinate. If I take its perpendicular distance from x-axis, that will be its y coordinate. I hope you are able to make clear sense out of it. Now moving ahead, let's see what do we see next. So here we have this quadrant theory, as we have already discussed how do quadrants behave and how do you treat them. Now there is one more pattern, one more system on the basis of which you relate or denote points. What does it say? Let me try and make you understand it through a very simple example. Let's say there is a point P, and this point P is given by, let's say, a point, let's say root 3 comma 1. So this point P is given by a coordinate root 3 comma 1. X coordinate is root 3, y coordinate is 1. Now what I know very clearly here is that this root 3 comma 1 means it's perpendicular distance here and this perpendicular distance here. I repeat, the perpendicular distance of this point from x-axis and the perpendicular distance of this point from y-axis. I hope I can make comments on that, because here we know that this point M will be having the coordinates root 3 comma 0, and if I drop a perpendicular from P to this y-axis here, let's call it N, then it will be having the coordinates 0 comma 1. So I hope there is no doubt or hesitation on that this distance OM is going to be root 3 and this distance PM is going to be 1. I hope you all are able to make some sense out of it, and that's exactly what we have been discussing. That if I drop a perpendicular from this point on the x-axis, it will be the y coordinate or the magnitude of the y coordinate. If I drop a perpendicular from this point P on the y-axis, it will be this particular length, I repeat, if I drop a perpendicular from this point P on the y-axis, it will be the x coordinate. So I hope there is no confusion on that. Now, what is the advantage of this particular system? The polar coordinate system, which we'll discuss in complex numbers as well. So don't worry about that. But here also, we'll have a clarity on this. So polar coordinate system says that, let's say there is a point root 3 comma 1 as per the Cartesian system, which we know. Now, this root 3 comma 1 in polar system can be written as, can you relate or can you connect this point root 3 comma with origin? I hope we all can. So there will be a straight line OP. Now can you find the distance of this point P from O? Let's call it R. So this R is basically nothing but the distance of point P from the origin. So the distance formula says root 3 minus 0 whole square plus 1 minus 0 whole square inside and under root, this entire expression, and that gives you 3 plus 1 4 and square root of 4 is 2. So this distance is clearly nothing but 2. That is the value of R. Now you need to define one more thing, which is theta. Can you define this theta? Sir, if I take this right angle triangle over here OMP, then I can say tan theta. I can say something about tan theta. What is this theta? This theta is the inclination of this line OP with respect to the positive x-axis in anti-clockwise direction. Now, what do I mean by this OP? This OP would mean that if I find tan theta, if I try to find tan theta here, tan theta would mean perpendicular upon base. So perpendicular is 1, base is root 3 as we have already figured out. So tan theta is going to be 1 by root 3. Can you help me with theta here, its principal value? We all know tan theta happens to be 1 by root 3 when theta is 30 degree. The principal value I'm talking about right now. So if I say that theta is going to be pi by 6, I hope there is no problem in saying so. So theta here is going to be pi by 6. So if previously I was defining a point uniquely as root 3 comma 1, this was a unique point, root 3 comma 1. No other point can have the coordinates root 3 comma 1 apart from this point P. So this point P can also be defined as r comma theta, which is 2 comma pi by 6. This point can be defined as 2 comma pi by 6. If this was the Cartesian system, this is the polar system or polar system, however you wish to pronounce it. My point is very simple, very straightforward. Do remember it, that here, what does this 2 mean? This 2 is basically what? This 2 is clearly nothing but r, and what is this pi by 6? That's theta. Now, what is the meaning of r? The magnitude, the modulus of this vector. What does it mean? The distance of this point from origin. What is theta? Theta is the inclination of this vector OP with respect to the positive x-axis measured in the anti-clockwise direction. There are some more conclusions which you should be aware of related to the polar system. Whenever you are measuring this angle is always from minus pi to pi. What does it mean? It means, for example, if there is a point in the first quadrant, of course, we measure it like this. If there is a point in the second quadrant, we will measure it like this. I hope there is no hesitation in that. But let's say if there is a point in the third quadrant, if let's say there is a point in the third quadrant, then we go in the clockwise direction. Then we go in the clockwise direction. If there is a point, let's say in the fourth quadrant, if there is a point in the fourth quadrant, then also we go in the clockwise direction. So any point, if it lies in the first or second quadrant, we go in the anti-clockwise direction and measure its inclination. For the polar Cartesian polar system, r theta, r comma theta. But if it is lying in the third or fourth quadrant, that theta is measured in the clockwise direction. If you want to define its r and theta, r will remain r only irrespective of the quadrant because it is basically the distance of that point from the origin. So that you can work out by using the distance formula. But when it comes to calculating theta in this polar system, you should stay aware that in the first and second quadrant, we'll take theta in the anti-clockwise direction. And if the point lies in the third and fourth quadrant, we'll take theta by measuring it in the clockwise direction. I hope you will remember that. Now, moving ahead. Of course, theta is something which we always take in radians. This is all what we have already discussed. I think I need not put more clarity on this. Now, there comes the very important, very crucial formula which you all must have at your fingertips. If you are preparing for IDG, this is something which you all are aware of. The distance formula, which says if there are 2 points x1 comma y1 and x2 comma y2, then the distance between these 2 points in the Cartesian plane is given by this formula. I hope you remember it. There is a point P which is given by x1 comma y1. There is another point Q which is given by x2 comma y2. Then by using this distance formula, you find the distance between these 2 points. Now, there is one more thing which is striking my brain, that let's say if I'm given this polar system and I wish to convert it into Cartesian system. So let's say this is your polar system and this is the point which is given by r comma theta. Now, can I define if let's say r and theta are given to me. Now, what is the meaning of r? R means the distance of this point P from origin. So that's your r. What is theta? Theta is the inclination of this, OP vector from the x-axis. Now, if you know r and theta, with a lot of ease, you can define its Cartesian coordinate points as well. So let's say if I know its x and y coordinate in Cartesian system, all you need to do is simply write r cos theta and r sin theta. That will be its Cartesian coordinate systems points. What I'm trying to make you understand is if this gives you the coordinates of this point in polar form, then this will give you the position of this point or the coordinates of this point in the standard rectangular coordinate system, which we have already discussed and understood, and the very basic phenomena which we always usually follow, right? Now, moving ahead, for example, this is something you have. Let's say previously, let's take the last questions only. What did we get? We got polar form as root 3 comma pi by 6. Do you remember that? Sorry, 2 comma pi by 6. So if 2 comma pi by 6 is given to me, which is basically r comma theta. And from this, I want to have the standard coordinate system. I want to have x and y coordinate in rectangular coordinate system. How can I have that? You need to simply take these two things in your mind. You should write r cos theta, which is 2 times cos pi by 6, and r sine theta, which is 2 times sine pi by 6. Did you get that? So I hope you know what is cos pi by 6, what is sin pi by 6. We know what is cos 30. Cos 30 is basically root 3 by 2. So 2 and 2 are cancelled. So you're left with root 3 here. What is sin pi by 6? That is sin 30, which is 1 by 2. So 2 by 2 is 1. And you're finally left with root 3 comma 1. That is exactly what we begin with. So I've tried telling you both conversions from standard Cartesian system to polar system, and now from polar to Cartesian. Did you get a great clarity on that? As we have already discussed with the distance formula, now let us move ahead with some more clarity, with some more concepts. What do we see? Now, the above formula is true for all positions. So yes, this is something we already know. So wherever the points lie, this particular formula can be applied in whichever quadrant the points lie. There is something more crucial, that if one of the points is 0, 0, so let's say basically you're trying to find the distance of a point from origin, what you do is under root over x square plus y square, because other point is 0, 0. Similarly, the above formula can also be used as x1 minus x2 whole square plus y1 minus y2 whole square, because when you square whatever it is going to be, it will become a non-negative value, right? So whether you write it as x2 minus x1 or x1 minus x2, it remains intact, it does not get affected. Now, moving ahead, the next few things are, let's say there is a point on the x-axis. Let's say there is a point on the x-axis, or there is a line which is parallel to the x-axis. So there are 2 points, let's say, which are lying on a line parallel to the x-axis. So let's say these are the 2 points. I hope you all are understanding it very clearly, that for both of these points, their y coordinates will remain same. For example, if this point has its coordinates as x1 comma y or y1, then this point will have its coordinates as x2 comma y1 only. Did you get that? So by using the distance formula, or by using some common sense, you will say, sir, that the distance between these 2 points is going to be mod over x2 minus x1, because now they can be in any quadrant, x1 or x2. I don't know which one is greater, which one is lesser. So I'll put a mod. So I'll take the difference so that I get the distance between them, but I'll put a mod because it can be negative. So I need to keep the distance to be positive. So I'll put a mod over it. Or if you don't understand this, we know that under root over x1 minus x2 square is not x1 minus x2. It is always mod over x2 minus x1 or mod over x1 minus x2. The same can be done for any point lying on a line parallel to the y-axis. Then you take the difference of their y coordinates. And I hope you have understood this particular concept with a lot clarity. Let's say if I were to prove that 3 points are collinear, how do I do that? With slopes also you can do it. Now, if I simply wish to use the distance formula, how do I do it? Let's say these 3 points A, B and C are told to be collinear. I'll find 3 things. 3 things I'll try to figure out. First of all, I'll try find the distance between A and B. Then I'll try to find the distance between B and C. And then I'll try to find the distance between A and C. Now I'll take any two distances, let's say AB and BC, and if I could prove that the sum of these 2 distances is equal to the third distance, then of course it is going to be collinear, because let's say if AB is found to be 2, BC is found to be 3, then AC is definitely bound to be found to be 5, because then only they'll be collinear. So you take these 3 distances, AB, BC and AC pairwise. And out of these three distances, if any two, the sum of any two can be represented as equal to the third, then we say that these 3 points are collinear. I hope this standard modus operandi and this standard procedure is understood by you all. Moving ahead with the next concept, what do we see next? I hope collinearity is very well understood by you all. Right? Now, I'll share some basic concepts which you should be aware of whenever you talk about triangles. What does it mean? See, this is something which they ask in questions. So sometimes you have to deal with parallelogram, sometimes you have to deal with rhombus, sometimes you deal with isosceles triangle. So there are certain properties you should be aware of, because the clarity you have, the more clarity you have, with more ease you can deal with such questions based on these concepts. So that's exactly what I'm trying to give you in this particular part. I hope this is something which is very simple and easy. Let's say whenever you are given an isosceles triangle, we can always apply this property that 2 of its side or 2 of its angles should be equal. So whenever two sides or two angles of a triangle are proven to be equal, we say that such triangle is going to be nothing but an isosceles triangle. Similarly, let's say if I'm talked about equilateral triangle, what I need to show is that all the sides or all the angles are equal, or if I could prove that all the angles are equal to 60 degrees, then we can claim that such triangle is going to be an equilateral triangle. Similarly, when you say that, sir, we need to prove that there is a right angle triangle, what do? I hope I need not tell you. The moment you see right angle triangle, what strikes your brain is Pythagoras theorem. So yes, whenever you see the right angle triangle, all you need to do is prove the Pythagoras theorem. If you could check it by proving the Pythagoras theorem, and if it is proved, then yes, we can undoubtedly, unhesitatingly say that this is a right angled triangle. Did you get that? I hope all the three triangles are very well understood by you all. What do I mean by isosceles right angled triangle? So let's say there are perpendicular and base, or basically there are two sides, and those two sides are equal. Once I have cracked that these two sides or these two angles are equal, then it is an isosceles triangle. But let's say sum of the squares of those two sides is equal to the square of the third side, length I'm mentioning, right? In that case, Pythagoras is also proven. So Pythagoras is also proved. So what we see is that it is isosceles as well as a right angle triangle, which means it is nothing but what? An isosceles right angled triangle. So two things are to be ensured, isosceles and then Pythagoras. I hope you are understanding it. Similarly, when you wish to prove a triangle to be a scalene, I hope I need not say anything. Either all the angles should be proven to be unequal, or all the sides should be proven unequal. In that case, you can claim that the triangle is scalene. My concern is, I hope you will remember these properties very clearly, because these properties are applied in the questions, and then deductions are made as per the requirement of the question. Now, let us move ahead towards the next part. What do we see next? These are also some standard generalizations which should you remember related to quadrilaterals. For example, when you talk about a square, what do you understand? Sir, if I wish to prove that a figure is a square, all I need to do is that all the four sides should be equal. But sir, all the four sides are equal in a rhombus as well. So can we say that it will be a square? No. All the four sides should be equal, and the diagonals should also be equal. So if these two conditions are fulfilled, then only we say that it is a square. Otherwise, the shape could be a rhombus as well if its sides are equal. I hope you know the difference. So in rhombus, the sides are equal, but the diagonals are unequal. But in square, diagonals are also equal. Both the diagonals are equal to each other. Similarly, let's say if I wish to check whether a figure is rhombus or not. So of course, as we have already learnt the difference, what I'll say is that yes, all the four sides should be equal. All the four sides should be equal, but in that case, the diagonals should not be equal, because if the diagonals also become equal, in that case the rhombus will be more specific, and that will be called specifically a square. Of course it will be a rhombus, but to be more specific, it will be a square then. Similarly, let's say I wish to prove that a quadrilateral is a rectangle. How do we prove that? All you need to do is simply prove that the opposite sides are equal. So pairwise opposite sides are equal, and the second thing, the diagonals should also be equal. If only the opposite sides are equal, then you'll say it is a parallelogram. But in parallelogram, diagonals are not equal. So if along with the pairwise opposite sides are equal, along with this you get the diagonals also to be equal, then you say that this is a rectangle. Otherwise, it will be a parallelogram. So I hope you're understanding the entire broader classification of the quadrilaterals through these properties. Moving ahead, let's say I wish to put my comment on a parallelogram, a figure to be a parallelogram, a quadrilateral to be a parallelogram. How do I check that? All I need to do is, again, as rectangle, the opposite sides should be equal. That is the first check you do. But the second check which you make should be simple, that yes, the diagonals should not be equal. If the diagonals also become equal, then of course it will remain a parallelogram, but the specific case of this will be that it should be called a rectangle in that case. It will be a parallelogram, it will still be a parallelogram, but to be more specific, that should be called a rectangle then. Yes. Now let's talk about a trapezium. So when you say or talk about a trapezium, what you say is, I hope you remember how does a trapezium look like. And I hope I need not draw these shapes. You know square, what is a square? In your brain, you know what is a rectangle, what is a rhombus, right? So let's say if you don't understand what is a trapezium, I hope I need not draw this, right? I am assuming that this is what you already know. So let's understand it through this property only. I'm just making you revise all this, which is what you have already studied till 8th and 9th standard only. I'm hoping that you know these shapes, right? Now, when you talk about trapezium, what we need to show is that the two sides are parallel. and the other two sides are not parallel. So if I could do that, I'll say that this is a trapezium. I repeat, if I could simply show you how does a trapezium look like, this is how a trapezium looks like. So this is the trapezium. Now what is the special, what's so special about it? That this pair of lines is parallel. So if any pair of lines or sides is parallel in that quadrilateral, then we call it a trapezium. Sir, can these two lines also be parallel? Yes, there could be a shape when you see all the four sides pairwise chosen, let's say these two and these two are parallel. Will it be a trapezium? Yes, it is a trapezium, but this is a more specific case of a parallelogram. So can it be called a trapezium? Yes, it can be. So that's the difference. But yes, if you want to say that is it a parallelogram? No. But is it a trapezium? Yes. Because at least one pair of lines, one pairs of sides is parallel. On the basis of that, you claim or conclude that this will be a trapezium. I hope you are building a great understanding on that. Moving ahead, what do we see next? What do I mean by an isosceles trapezium? Now let's have a look at that isosceles trapezium understanding. So isosceles trapezium means that two sides are parallel and the other two sides are not parallel but equal. If something like that happens, then we call it an isosceles trapezium. I repeat, it's a very simple phenomena here. Let's say if in a trapezium, you see that the pair of one sides is parallel. So these two sides are parallel, but the other two sides which were unequal are the other two sides which are non-parallel are equal. Of course, in that case, they'll subtend same equal angle here on these sides. So that's why you remember, that's why you should remember that this is going to be an isosceles trapezium. I hope there is no confusion on it. This is a special case which you should remember. So in case if you forget that, do remember that this is also something which we have discussed and studied. Don't forget this particular case, right? Moving ahead towards the next set of rules, next set of one day, what do we explore now? Let's say we are told that ABC are the vertices of a triangle and we have to find the coordinates of the circumcenter. Then the circumcenter PXY can be found with the help of the simple data. I'll just demonstrate it with an example. For example, let's say there is a triangle. Let's say there is a random triangle, something like this, right? So this is the triangle over here. And I describe a circle on it. What do I mean by that? So I'm drawing a circle over here like this, and what is special about that circle? That this circle passes through all the three vertices of this triangle. I hope you can see it very clearly right there in front of you. Now, why are we discussing this? Please understand, this circle would be having a center, and that center will be called the circumcenter. So there was a triangle. Let's say there is a triangle A, BC. And if I were to define or find its circumcenter, how do we do that? It's a very simple phenomena that since it is the center of that circle, which passes through all the three vertices of the triangle, which means, can I not conclude that all the three vertices are equidistant? All the three vertices are equidistant from this center. So what I'll do is, let's say I'm given A, B, C. I'm given the coordinates of A, B, and C. So I'm given A, which is let's say x1, y1. I'm given B, which is let's say x2, y2. I'm given C as well, which is let's say x3, y3. So how to find this circumcenter? Let's say I'm denoting it by P right now. So how do we find the coordinates of P? The approach is very simple, students. What I do is I'll begin with PA. I'll find PA, or rather I'll find PA square, because I wish to remove this under root sign. Then I'll find the distance between PB, and of course I'll put a square sign over there, and I'll find the distance PC and I'll put a square sign over there. Do you not agree that PA, PB and PC, all three distances are going to be equal because they are circumradius? So if all these three distances are equal, PA, PB and PC, I can say that PA square will be equal to PB square will be equal to PC square. From here, what you'll get is, you'll get PA square is equals to PB square. You'll create one equation in X and Y, because let's say the coordinates of P are either H comma K or X comma Y, whatever you wish to take it. This is what we need to figure out. So here, our relation, one equation can be attained by putting PA square is equals to PB square, and you can get the second equation by putting PB square is equals to PC square. So you'll get two equations in H comma K or X comma Y, whatever variables you take. So again, you will have simple linear equations in X comma Y or H comma K, two equations, and you know how to solve them. So two equations in two variables, linear equations, you know how to solve them, and by solving them, you can find the coordinates of H comma K. And that's how, with this much ease, you can find the circumcenter of a triangle. The three coordinates are given. All you need to do is that circumcenter is equidistant from all the three vertices. So that distance formula can be used. Two equations will be formed in h comma k. Two linear equations, two variables, two unknown. You can find them by solving either by substitutions or elimination. I hope you remember that. So that's how you will follow or you'll find the circumcenter. That's the method we'll follow. I hope no confusion on that. Let us move ahead and let us see what do we find next. Yes, this is also a formula. I don't ask you to remember it. Forget it. Simply skip it. This is also something I'll ask you to skip this. What does it say? I'll try and tell you that instead of remembering this formula, which is very confusing, what does it say? That let's say there is a triangle, which is a right angle triangle. Let's say there is a triangle here, which is a right angle triangle, right? So let's say I'm given the vertices of, let's say, hypotenuse. So there is this hypotenuse which is having extremes as, let's say, x1 comma y1 and x2 comma y2. So of course you can use that formula if you could remember it, but I highly suspect and doubt that. Will you be able to remember all these formulae? So what I'm suggesting here is that let's say I wish to find out the third point, this vertex where the right angle is created. Let's denote it by h comma k. How do I find h comma k? The formula is very simple here, students. What I know is, first of all, I'll apply the Pythagoras theorem. What does Pythagoras say? That if this is A, this is B, and this is C, Pythagoras says that AC square plus BC square should be equal to AB square. So that's the first check you do. What do you do? AC square plus BC square is equal to AB square. So through Pythagoras, you will be able to establish a relationship between h comma k. One equation will get formed. I hope it will be a very simple equation. The second relation which you can create by doing is the very simple phenomena that here, since this is a 90-degree angle, what you can do additionally is you can find the slope of this line. Let us denote it by MBC. You can find the slope of this line. Let us denote it by MAC. And we know that both of these lines are perpendicular. And if both of these lines are perpendicular, what we know is that if these two lines are perpendicular, the product of their slopes will be -1. So by having these two results, first result which will attain by applying Pythagoras theorem, second result which will attain by applying this perpendicularity of two lines, that if two lines are perpendicular, the product of their slopes is -1. So by having these two conditions fulfilled, you can find the coordinates of h comma k. Why? Because h comma k, two variables are there, so I need two equations. So one equation in h comma k can be attained by applying Pythagoras. Second equation or relation in h comma k can be attained by using this perpendicularity. And through that, you can find the coordinates of this point C, where the right angle is getting created. Did you understand it? There are some more approaches which we will keep exploring the moment we start understanding few more concepts. So the better understanding of concepts you start building, the better awareness you'll have of such logics. And you will be able to think of these logics by yourself once you start getting clarity about different concepts. So I'm just giving you the different mindset which is required to solve certain level of questions. So I'm categorizing questions and I'm putting under them certain category, that if this question or this category of questions is asked, or if this kind of information is needed to be brought, then this kind of approach can be thought of. This kind of idea can be applied, right? Similarly, there is some more results of formula. This is something when you are given an equilateral triangle. So let's say there is an equilateral triangle given to us. You can remember this formula. I am of course going to share this sheet with you, the notes with you. You can revise the formula. You can try to learn them, but I highly again suspect that you'll be able to. So what I'm saying is that let's say there is an equilateral triangle. There is an equilateral triangle whose two vertices, let's say x1 comma y1 and x2 comma y2 is given. Now I need to find out the third vertex. How do we do that? Do you remember, as we have already discussed, circumcenter is also something like that only, which uses the same distance formula concept. So let's say here there is this third vertex. This was A, this was B, and this is C. So what do I know here? I know a very interesting phenomena which says that, sir, here you can use this thing, that AC square, AB square, and BC square are going to be same. Can I not say that this is an equilateral triangle? Then AB square, the distance of AB will be equal to BC and will be equal to AC. But since in the distance formula we have to deal with the under root expression as well. So to remove that square root, I'm putting square sign over there. And with that again, I'll put any two equal. I'll take pairwise any two. For example, if I take AB square is equals to BC square, I'll get an equation in h comma k. When I take BC square is equals to AC square, I'll get another equation in H comma K. Again, two equations, two variables. Will you not be able to solve this? By solving them, you can find H comma K and that will be your answer. Did you understand this? I hope you are understanding it very clearly. Of course, in the previous can, in this case, you will get two answers. Why am I saying so? Please understand, let's say A and B are fixed. Let's say A and B are fixed. So why can you have only one coordinate C fulfilling this condition? Why can you not have another point C here as well? So when you solve these two conditions, when you create these two relations and finally find the coordinate of C, you'll get two answers. One C here and another C here. Because for this C and C dash both, this AB will be behaving as a hypotenuse and a right angle triangle will get formed. In the same fashion, let's say if I look at this AB, which is fixed. So do you not think that there will be one more possibility of C? What do I mean by that? Let's say if I create another vertex here as this, let's say, although I'm not drawing it very properly, but I hope you are able to make some good sense out of it. Let's say this is how I do it. This vertex C here, this C dash. For this C dash also, this ABC dash, an equilateral triangle will get formed. So even while solving these conditions, this and this, you'll get two solutions. One solution for this C, other solution for this C. I hope you're understanding this. I hope you are getting a great clarity on this part. Now, there comes another formula, section formula. This is something we have discussed in vectors in 3D. This is something we have discussed specifically in vectors, specifically in 3D. And there also, I had given you the reference of 2D, of coordinate geometry, that this is exactly is nothing but an extension of what we will study in straight lines. So this is exactly what we are seeing right now. I hope you remember that if, let's say, there are 2 points, I'll draw them here. So let's say there is a point x1 comma y1 here and another point which is x2 comma y2 here. I hope you remember that. Now, somewhere between these 2 points, let's say A and B, there is another point C. But what we know about this C is that this ratio AC is to BC is m is to n. Let's say this ratio AC is to BC is m is to n. So this length is m and this ratio is n in terms of ratios. So by having this much information, we can work out what is going to be the coordinate of C. How? I hope you remember, coordinates of C are going to be really simple. How? M times x2 y2 and n times x1 y1 upon m plus n will give you the coordinates of C. What am I trying to say is that m times x2 plus n times x1 divided by m plus n, that will be the x coordinate of C. And similarly, what about the y coordinate? M times y2 plus n times y1 upon m plus n will be the y coordinate. I'm running short of space there, so I'm not able to write it, but you have these written over here only. So did you get that? I hope you are aware of section formula, which we have already discussed in vectors in 3D, and we are re-repeating it again, right? Similarly, if I could give you more clarity about something very useful, let's say there is this point. Which is the midpoint of these 2 points. So let's say this is A and this is B. So let's say A has coordinates 2, 1. B has the, there is C point, which is the midpoint of A and B, and C has the coordinates, let's say 4, 2. C has the coordinates 4, 2. Can you now directly not write the coordinates of B? One of the ways is, so assume B is alpha comma beta, then alpha plus 2 by 2 will be 4, beta plus 1 by 2 will be 2. Rather, there is a standard method. What you say is that, sir, double of this minus this will also be this. Because this plus this divided by 2 was this. So double of this minus this will be this. What I'm trying to say here is double of 4, it is 8. 8 minus 2 is 6. So this will be 6. Double of 2 is 4. 4 minus 1 is nothing but what? 3. So this is going to be 6, 3. So this is a very standard formula, basically a very basic awareness. If you solve more questions like that, such understanding can be built or brought by you very easily. This is something which I do to remember. I hope this is something we have already discussed and learned. And similarly, let's say if sometimes we are asked to find the ratio in which, let's say, 2 points are divided by the third point, the ratio in which the line segment created by joining 2 points is divided by the third point. In that case, instead of treating that ratio as m is to n, I'll suggest that you should treat that ratio as lambda is to 1. Because let's say finally after solving the question, you get lambda as 3 is to 2. You get lambda is to 1 as 3 by 2. So lambda is to 1 means what? M is to n, which means 3 is to 2. I hope you're understanding it. So instead of introducing two variables in your equation and making it unnecessarily complicated, take one variable only whenever it talks about the ratio. I repeat, instead of taking m is to n, two variables, take one ratio only, lambda is to 1, and there you have only one variable, so that your equations won't look complicated. I hope you are able to digest my part very clearly here. Now, of course, when you solve such questions, whenever the division happens internally, lambda will be found to be positive. And if after solving, you find, let's say, lambda is turning out to be minus 3 by 2. So minus depicts an external division. 3 is to 2 will be the ratio, but minus sign will help you in deducting that this division was an external division. I hope you are able to deduce that part as well. Moving ahead towards the next part, the next remark, which is a short trick, which is a short technique, which is what we have discussed in 3D as well. How do we apply this in 2D? Let me demonstrate it here. Let's say there is a straight line ax plus by plus c is equals to 0. And this straight line divides this line segment created by joining the points a and b, x1, y1 and x2, y2 in a ratio. And we are asked to find that ratio. The short technique says a very simple phenomena that find the power of this point with respect to this line, write it here. Find the power of this point with respect to this line, write it here. Take the negative ratio of these powers. You will have the ratio AP is to BP. What I'm trying to make you understand is a very simple fact here. Please understand that let's say there is a straight line. This straight line is, let's say, x plus y minus 3 is equal to 0. And there are 2 points. There are 2 points. Now, those 2 points can be anywhere. So, these are the 2 points. Let's say one of the points is 5, 2 and the other point is, let's say, 1, 3. Now, I wish to find out that in what ratio this line, in what ratio this line is dividing this into. So, let's say that ratio is lambda is to 1. So, the short trick says that this lambda is to 1 is going to be nothing but negative of ratio of powers of these points with respect to this line. What do I mean by power? Put 1, 3 in place of x, y in this line. So 1, 3. So 1 plus 3 minus 3 is going to be 1. I hope there is no doubt on that. 1 plus 3 minus 3. Now, power of 5, 2 with respect to this line will be 5 plus 2 minus 3. 5 plus 2 is 7. 7 minus 3 is 4. So this is going to be 4. Now the ratio is found to be minus 1 by 4. So the ratio will be 1 is to 4. This ratio will be 1 is to 4. But this line wouldn't be dividing it internally. This division will be happening externally. So that is another conclusion which you can draw with the help of this negative sign. Are you able to digest this short technique? Did you understand this short formula? You need not use that standard method which you have learned during boards. That is something which you should avoid. This short technique will help you a lot in solving a lot of questions within seconds. So remember this. This is something very important. A standard formula which we have discussed, a standard result. And if you were to apply this, you will get the answers within 10 seconds. And we have already demonstrated this right there in front of you through this technique. These are some simple applications of that only. So remember that. Now, there comes a very important conclusion that in these shapes, in these figures, which figures, students, whenever you talk about a square, rhombus, rectangle or a parallelogram, the diagonals always bisect each other. The diagonals always bisect each other. Do remember this as a property. Let's say if I talk about a square, then the diagonals bisect, which means this and this will have the same midpoint. Whenever I talk about, let's say, a parallelogram, so the midpoint of this diagonal, and the midpoint of other diagonal will be same. That's what I'm trying to say. Even if I take a rhombus, even if I take a rectangle, the same will hold true. If it is true for parallelogram, rectangle, rhombus and square are subsets of it. So if it is true for parallelogram, it will be true for other three as well. I hope you're understanding why. Now, moving ahead towards the next concept, what do we see next? We see the external division formula. As we already know, if it is an external division, m is to n will remain like that only, but the value, the positive sign will become negative, as we have already discussed previously and also in vectors in 3D as well. So I don't think that I need to explain that part. There comes another part which is called centroid of a triangle. So let's say there is a triangle given to us. And this is the triangle. This triangle has vertices x1, y1, x2, y2 and x3, y3 like this A, B and C. Of course, centroid is the point of intersection of all the medians. So if this is the median CF, So this F will be the midpoint of AB, which you can find by this. This E, BE will be another median. So E is the midpoint of AC. You can find by using this section formula. This D is the midpoint of BC. So here AD is the another median. So by having these three medians, I hope you know this other property as well, where we know that this centroid divides any median into the ratio 2:1. So here we know that G will be dividing AG into 2:1 into 2:1. So 2 into this plus 1 into this divided by 2 plus 1, which is 3, will be the coordinates of G. So by using this, you find the coordinates of G, which is nothing but what? X1 plus X2 plus X3 by 3, comma Y1 plus Y2 plus Y3 by 3. That is how you write the coordinates of the centroid of a triangle. Will you remember it? Whenever somebody asks you, how do you define the centroid of a triangle? If its vertices are given, take the sum of the vertices, X coordinate and Y coordinate respectively, and divide that sum by 3. You will get the centroid's coordinate. Did you get that part? I hope there is no confusion on that front. Moving ahead towards the next part here. Remember, let's say there is a triangle given to you. Let's say there is a triangle given to you. I'll just draw this triangle over here. Give me a second, students. Let's say this is a triangle. This over here is a triangle. Now, in this triangle, let's say this point is x1 comma y1. Or even if let's say the points are not given, this is A, this is B, and this is C. This can be any kind of triangle. So in this triangle, let's say I'm given the midpoints. I'm given the midpoints. So these midpoints are given and let's call them D, E, and F. So this is D, this is E, and this is F. D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. I hope there is no confusion on that. And let's say these coordinates D, E, F are given by this A1, B1, A2, B2, and A3, B3. They are D, E, F, F. Even for this triangle also, which you create by joining these midpoints D, E, and F, they will also have the same centroid which this bigger triangle has. Not just that, even if I join their midpoints DF, BF, DF, EF, and DE, even if I take their midpoints, that triangle will also have the same centroid. I hope you're understanding this phenomena. So even if I'm given the midpoints, I need not find ABC and then find the centroid. No, you don't need to do that. You can say that A1 plus A2 plus A3 by 3, B1 plus B2 plus B3 by 3 will also give you the same centroid. Did you get that part? So centroid attained by the triangle, by the vertices of the triangle, or by the midpoints of the sides will remain same. That's a fact. Remember it. It is again something very useful. It is used at a lot of places. Now, let us move ahead towards the next part. This is a finger rule which I want you all to learn because it is going to be used at a lot of places directly as a shortcut. Let's take an example and understand this particular result. For example, we have a triangle, right? And its midpoints, the midpoints of the sides are given. For example, any triangle it is, let's say 1, 2 is there. Let's say it is 0, 3, let's say, and this one is, let's say, any point, let's say, any point. Let's take 2, 4. I'm randomly taking any point, right? So now, what do we do? Let's say if I wish to find the vertices of this triangle, how do we do it? So the idea is very simple, students. Let's say I want to find the vertices of this. So one of the methods is, let's say this is alpha comma beta, then you use midpoint theorem, then you define this, then you define this, and then you define this. And through midpoint theorem, the section formula, you find it. There is a short technique. What is that short technique? The short technique says sum of these two minus this will be this. What did I just say? I said 2 plus 0, which is 2, minus 1 is 1. So this is 1. Did you get that? Similarly, 4 plus 3, which is 7, minus 2 will be 5. So this is going to be 1, 5. How do I find this one? I hope I can find this one very easily. Now, how do I do it? Sum of these two minus this will be this. I hope you have understood the trick. So it says 2 plus 1 is 3. 2 plus 1 is 3 minus 0 is 3. Similarly, 4 plus 2 is 6 minus 3 is 3. So this is going to be 3, 3. Similarly, can you find this one and write in the comment box what is it going to be? I'll be really happy if some of you could do it. Rather, every one of you, whosoever is watching it, could do it. Similarly, this is something related to the centroid, which let's not discuss. Simple formula let us remember for centroid: x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. Through that, you can work out all the other results as well. Now, this is something you should remember. I'll simply give you this idea that let's say if I join these midpoints, let's say this is a triangle, this is a triangle. And if I join its midpoints, if I join its midpoints, this midpoints of the sides of course. So this triangle is divided into 4 triangles. Remember that all these 4 triangles are going to be of equal areas. So let's say if the bigger triangle, let's say the triangle is ABC. So if the bigger triangle has an area delta, let's say the area of the triangle, bigger triangle is delta, so then all these smaller triangles will have the area delta by 4, delta by 4, delta by 4 and delta by 4. I hope you're understanding this reason. Everyone with me on this? Can we move ahead with this conclusion? Remember these properties which I'm giving you, the results, they are applied in the questions and you solve a lot of questions based on these results. For example, this one. What do you mean by in-center? So as we have already discussed in vectors in 3D as well, in-center is basically going to be the intersection of internal angle bisectors of the angles in a triangle is called the in-center. Now what does it mean? It means, for example, there is a triangle. A triangle looks like this. Now in this triangle, I have drawn the angle bisector of this angle A, which is A by 2, A by 2, angle B, which is B by 2, B by 2, and here angle C, C by 2, C by 2. So these are the 3 angle bisectors, internal angle bisectors. All these 3 internal angle bisectors will be concurrent, which means all of them will pass through one single point that will be denoted by, let's say, capital I, and this I is going to be the center of the circle, which passes through all the 3 sides of this triangle. What I'm trying to make you understand is, which passes through means which touches all the 3 sides of this triangle. I'm really sorry for that. What do I mean by this? Let's say there is a triangle. Let us say there is a triangle. I'm trying to draw it here. So this particular triangle has a circle inside it, which touches all the 3 sides of this triangle like this. I hope you can see it very clearly, which touches all the 3 sides of this triangle like this. Although the point where it touches, the circle could be different from these points. These internal angle bisectors will go somewhere else. So these E, D and F will not be the feet of the perpendiculars. For example, from here, let's say I drop a perpendicular here, this will go like this. From here, let's say I drop a perpendicular, this will go like this, and this will be the point of contact, this will be the point of contact here. Let's say this is the point of contact here. So from here, if I drop a perpendicular here, this will be that feet. And remember, these are going to be the in radius, the radius of that smaller circle which we have drawn inside the triangle. So in center is the point of intersection of the internal angle bisectors. There you have this in radius, and the center is going to be the in center. I hope when you inscribe a circle in a triangle, of course in a triangle, then you get the in center. The in center is the center of that inscribed circle. How do we get that? By having the point of intersection of all the internal angle bisectors. There is a formula as well, but let's not bother about that. Similarly, there is a formula for x-center as well. X-center means what? You take the external angle bisectors. For example, here, let's say there is a triangle ABC. This is a triangle ABC. So I take the external angle bisector of this vertex A, I take the external angle bisector of this vertex B, and I take the internal angle bisector of this vertex C, and at this point when they are concurrent, this is called external x-center. Similarly, I'll have another x-center here, another x-center here. What is special about these circles? These circles are also touching all the 3 vertices. All the 3 vertices, but this time externally. I hope you're understanding it. So X circle means, again there is a circle which touches all the, not all the 3 vertices, all the 3 edges. So all the 3 edges of this triangle, but externally this time. Previously it was the contact was happening internally, that was in circle, it is X circle. And the center of this circle will be X center. And such 3 X circles will be drawn for a triangle. And X center is achieved by having the point of intersection of external angle bisector. Did you get that? I hope it is understandable. Similarly, there is a formula for X center as well. Now, let's talk about some other result as well, which is called circumcenter of a triangle. Usually, the questions are framed on either circumcenter or orthocenter. That is the most crucial part. So, now we'll be talking about circumcenter, which is going to play a very crucial role. After discussing straight lines, I'll give you one more approach through which you can find the circumcenter. That method we'll discuss later. But as of now, I hope you understand that whenever you draw a triangle and there is a circle which passes through all the 3 vertices of it, then the center of that circle is called the circumcenter. What is interesting here is that this center is nothing but the point of intersection of all the perpendicular bisectors of all the three sides. The perpendicular bisectors of all the three sides. So this O, which is the circumcenter, is nothing but the point of intersection of all the perpendicular bisectors. They are also concurrent for any triangle. And from this point O, B, A and C are equidistant. They are called the circumradius. And by using this property only, we find the circumcenter, as we have already discussed in the lecture only previously as well. But there will be one more method which we'll be discussing later. Remember that method as well. We'll talk about that by using this perpendicular bisector concept only, but after discussing straight lines, because it uses the concept of straight lines. So don't forget, we'll be using or we'll be having more clarity on that. Now, after circumcenter, let us understand what is the orthocenter. This is not something you need to remember. Circumcenter of the right angled triangle is at right angle, which is at vertex A. What do I mean by that? Let me just simply draw it and show it to you. For example, there is a circle. Imagine there is a circle, right? And let's say there is a right angled triangle. There is, let's say, a right angled triangle. I hope you can see it getting created like this. There is no confusion on that. Now, what you must be noticing here is, let me take a different color for that so that you don't get confused. So let's say here, what you all must be noticing is that there is a circle and there is a right angle triangle. So this is a right angle triangle having vertices A, B, okay, give me a second, having vertices as A, B and C. These are the three vertices. Can you see them? Now, what you must be noticing is that this is a right angle triangle and this is right angled at B. This is right angled at B. Now, for this right angled triangle, I hope you see that the midpoint of the hypotenuse AC, the midpoint of the hypotenuse AC is going to be the circumcenter of this triangle. I hope I need not explain why. Why? Because this hypotenuse, which is behaving as a diameter for the circle, is subtending a 90-degree angle at its circumference, which is a property of a triangle or a circle basically. So if this is the diameter, which is the hypotenuse for this right angle triangle, then the midpoint of the diameter will be the center of the circle. So the midpoint of the hypotenuse will be the center of the circle. So circumcenter for a right angle triangle will lie at the midpoint of the hypotenuse. That's exactly what they are trying to say. These are some general facts I'm giving you one after another. I hope you are not bombarded by them and you are understanding and taking notes of everything very clearly. Because any of these can be used anywhere and the questions can be done with these logics, with these theorems, with these concepts, which we are trying to give you in this one shot. This may look heavy, but a lot of information is given to you. Take notes of all of these things, although notes are also provided to you, but keep taking notes of whatever important is being discussed. Similarly, there are some more results, some more conclusions. For example, what do you mean by orthocenter? Again, a very simple, very standard phenomena. We have had a discussion on this in vectors in 3D as well, twice. Now this time, third time I'm having this discussion here. Let's say this is vertex A. From this vertex A, I drop a perpendicular AD on the side BC. Similarly, from B also an altitude is dropped. From vertex C also an altitude CF is dropped. All these altitudes are also concurrent and they intersect at a point, let's call it H. So this point H is called the orthocenter. Again, there is a formula for it. You need not remember it. The standard method is also what we'll be discussing. So we'll be discussing it once we start discussing the straight lines. I'll give you a standard formula, slope or basic method through which you can find the orthocenter of any triangle. So don't worry about that. We'll understand a logical approach instead of learning a formula. And that's exactly what they do. These are some results. You can learn them. You can revise them by yourself as well. But as of now, in this one shot, we are skipping that. Now we are coming to the part where we'll be discussing how do you find the area of a polygon. Do you remember? This is exactly what we have discussed in the chapter determinants as well. Do you remember that stair method we have given you? That same method I'll be re-explaining in this part as well. Now let's say there is a polygon. Let's say there is a polygon. Any sort of polygon, let's say we are having. So let's say I have a polygon like this. How do we draw a polygon like this? Let's say I have a polygon like this. So this is the polygon, right? This is the polygon, a pentagon basically. So this pentagon has some vertices. This pentagon has some vertices. Let's denote them. Let's call it A, B, C, D, and E. Now just ensure that you are following the cyclicity. What do I mean by cyclicity? You stay either clockwise or anti-clockwise. So with whichever vertex you wish to begin with that vertex. and on that same vertex only, but maintain cyclicity. You can go either clockwise or anti-clockwise, but you cannot shuffle. You cannot abruptly jump here and there. So let's say I'm starting with vertex A. So let's say vertex A has coordinates x1, y1, B is x2, y2, C is x3, y3, D is x4, y4, E is x5, y5. So let's say I wish to find the area of this polygon, area of this basically pentagon. How do we do it? So the stair method says that take half of modulus of. By stair, I'll get a value. It can be negative, 0 or positive. So if it is negative or 0, I need to make it positive. Of course, 0 cannot be made positive, but if it is negative, I need to make it positive. And that's why I'm putting a mod over it, because this is an area. And if it is the area, it should be positive or 0. If it is 0, it means the points must be collinear. Now, with that, if I write the stair, now what do I mean by stair? Stair says you begin with whichever vertex you wish to begin with. Let's say I'm starting with A. So I've chosen A. Let's write the coordinates of A, which are x1, y1. Now I have the liberty to go either clockwise or anti-clockwise. Now you need to choose one side. So let's say I've chosen clockwise direction. So after A, I'll go to B. So I'll write the coordinates of B, which are x2, y2. Then the coordinates of C, which are x3, y3. Then the coordinates of D, which are x4, y4. Then the coordinates of F, which are x5, y5. Now you need to end with the vertex with which you had begun with. So I had started with x1, y1. So I'll write x1, y1 again. Now, how do I expand a stair? So expansion was also told while understanding the chapter determinants. Expansion says x1, y2 minus x2, y1 plus x2, y3 minus x3, y2 plus x3, y4 minus x3, x4, y3 plus x5, y5 minus x5, y4 plus x5, y1 minus x1, y5. After getting this result, you will have either a negative value or a positive or a 0, but put a mod over it and take half of it. That will give you the area of the polygon. This stair is exactly what we have learnt while discussing the chapter determinants, or this can be done through determinant as well. And this is exactly what we have written over here for your convenience. You can revise it from here, but I have given you a complete clarity that from if you go downward, you take the sign positive. If you go upward, you take the sign negative. I hope you can see it very clearly here. I hope there is no confusion. x1, y2 positive, x2, y1 negative, x2, y3 positive, x3, y2 negative, and that's how you keep going. That's how you find area of any polygon. Can you believe this? You need not remember any formula. You need not remember the formula of any kind of triangle, any special kind of triangle. A triangle which is equilateral, there is a formula. A triangle which is isosceles, there is another formula. For even quadrilaterals, there are different formulae. But here, for all polygon, triangle, quadrilateral, pentagon, hexagon, heptagon, they have only one single formula. Are you realizing the beauty of coordinate geometry? And that's what you should remember here in this particular case. Now, moving ahead with this stair method, what do we see next? Yes, these are some simple conclusions. If the area of the triangle is 0, then of course the points are collinear. So for collinearity, there was condition that you check it with the distance formula or with the area formula. The third method will be slope, which we will be discussing later after discussing the concept of slope. Another point is that if 4 points are given and they are asked to be collinear, then the quadrilateral's area should be 0, as we have already discussed here. And yes, if the area of the triangle is given, then use plus minus sign. In the questions, let's say if I'm told that let's say the area of the triangle is 3. So I'll say, of course, the area of the triangle ABC is 3. Let's say this is given. So if I were to use it through stair method, and let's say I'm asked to find out a certain value or certain coordinate, so I'll say half of mod of stair of something will be 3. So I'll take this half there and then I'll remove this mod. So when I remove this mod, I'm supposed to put plus minus 3. What students usually do is they avoid, shifting this mod over there as a plus minus sign, and they take plus 3 only. And that's where they commit the error. They get only one answer. And what should you know is that there are chances that you will be getting 2 answers. And because of that, students commit errors like that. So such silly errors should be avoided. And whenever area is given and when you're solving it in the reverse manner, and when you remove this mod, you should use the plus minus sign. I hope you are understanding and remembering why. Now, understanding and realizing why, right? Now, this is something which I don't ask you to remember. This is something which will give you in the notes, but don't remember. Remember the stair method. That's the, Sanjeevni or the Brahmastra which you should carry with yourself. That will help you everywhere. Let's consolidate whatever we have learned so far by this example, through this example. What does it say? It is basically a question, a decent example asked by JEE Mains in 2025. It says that A, B, C are the vertices of a triangle. Okay. Then the maximum area of a parallelogram AFDE, okay, formed with vertices DEF on the sides BC, CA and AB. Okay, let me draw it because in coordinate geometry, this visualization is very crucial and very important. So let me draw this triangle first of all, ABC. So there will be a triangle ABC. All right. So it will have its own vertices. So this will be A, let's say this is B and this is C. So what is A? A is given as 4, minus 2. Okay. What is B? B is given as 1, 1. Okay. What is C? C is given as 9, minus 3. Great. Now what they do is they are forming a parallelogram with the vertices D, E, F. What is D? D is a side on, D is a point on BC. Okay, D is a point on BC. And CA and AB. So E is on CA. So I have BC, CA and AB. All the three sides basically. Okay. And the fourth vertex should be A. Okay, on the fourth vertex should be A. Great. I will try to form a parallelogram here. Let me just do that. Let me just try and do that. Let's say there you see a line like this. I hope you are able to digest this particular part which I have drawn here. And there I draw another line. I'm just trying to ensure that it remains a parallelogram here like this. So this is another line. Let me do this. So what you must be noticing here is, let me label these points so that it becomes more understandable. What I've done is I have chosen these 3 points. In what manner? D on BC. So on BC this is D. So this point should be labeled as D. And then E on CA. So on CA, this is E. And I hope I need not tell you the other point is F, which is on AB, probably and possibly. Yes, that's the only possibility you're left with. So we are seeing a quadrilateral getting formed. Can you see a quadrilateral getting formed here? The quadrilateral clearly looks like this quadrilateral. I hope you all have noticed it very clearly. Now I have deliberately designed it like this. I have a motive behind this particular formation. This quadrilateral AFDE is said to be a parallelogram. This is given as a parallelogram. Now, what is the meaning of this quadrilateral being a parallelogram? It means that DE is parallel to AF. I hope I need not tell that. And DF is parallel to EA. I hope you're getting it very clearly. There is no confusion on that. Now, moving ahead, what do we see next? What results do we get? I'm simply trying to give you some basic conclusions. For example, here, if this AF and ED are parallel, this AB, AF, whatever you wish to call it, and ED are parallel, then will you not say that this angle over here and this angle over here should be same? Along with this, what you also should notice is that, let's say here, if I talk about some other triangles, for example, I'll just form one more triangle here with the help of this. Let me join this EF here. I hope we can join this EF, and all of you must agree that EF will be parallel to BC in that case. Why am I saying so? Because I am trying to give you a very simple conclusion here. I'm trying to give you a very simple conclusion here that look at this part. This angle and this angle are same. I hope I need not prove it. Similarly, this angle and this angle are same. I hope you remember it. Similarly, along with this, I can draw a lot of conclusions. My point here is very simple, that with this conclusion, when you are trying to maximize this area, which area? The area of this parallelogram, then of course, you are wanting to have this area to be as much as possible. So one thing based on intuition, you can say that, sir, let's say if I choose F here and if I try to form a parallelogram like this, then of course this triangle, this quadrilateral, this parallelogram will have lesser area than this one, which I am creating as an optimized one, because this one I'll be getting the maximum area I'll be getting when these are the midpoints. I'll try and prove how. See, let us say this and this, what we have created so far, this this FD and this ED is something which we need to create, because this and this should form a parallelogram here. I hope this is something you are all able to understand. So what we know so far is, even if I don't know that this EF is parallel to this BC, what I still know is that this is parallel to this, which means if this angle and this angle must be same. Not just that, this is parallel to this, which means this angle and this angle must be same. On the basis of this, you are finding a similarity that this triangle will be similar to this triangle. This triangle will be similar to this triangle. And these two smaller triangles will be similar to this triangle as well. Although I'm not writing it completely because intuition based understanding is needed here. So what we are trying to prove here is that all these triangles are similar. Now my next conclusion is they are not just similar, but they have the same area because they are congruent. I repeat, if the entire triangle's area is delta, then they are 1/4. All the triangles are having the same area, they are congruent. I hope you're understanding it very clearly. Because by symmetry, we can prove it. So once you have proved the symmetry here, once you have seen the symmetry here, you can come to this conclusion that if the entire triangle's area is delta, all these triangles are 1/4 of that. In order to have the maximum area of this triangle A of this parallelogram AFDE. Otherwise, let's say if I take F here, if I create a parallelogram here like this, it will be minimized. So the maximum area is found when it is equally distributed like this only. Did you understand this optimization? Through maxima and minima also you can prove it, but I think this is sufficient here at this stage. What I now understand is, let's say if this is, let's say this area is X, this area is X, this area is X, and this area is X. So the total area of the triangle should be 4X, and I am looking for the area of the parallelogram. So basically I'm looking for 2X, which is half of the area of the triangle. Because if the area of the triangle ABC, we have already created X plus X plus X plus X, which is 4X. So I'm looking for 2X. So all I need to do is, I hope you're understanding it very clearly, I am asking you the area of the parallelogram. Which parallelogram, students? I'm asking you the area of the parallelogram AFDE. And that should be nothing but what? Half of the area of the triangle ABC. Did you get that conclusion very clearly? I hope there is no confusion on that. So let us find the area of the triangle ABC, half it, and then we'll get the area of this parallelogram. More importantly, are you able to digest this fact that this will be the maximum area only? You cannot have more than that, because that's how you can divide this area into all these 4 regions symmetrically and equally. With that, if I come to this conclusion that I want to have this triangle ABC's area, because half of that will be my answer. So area of the triangle ABC is given by, I hope you remember, half of mod of stair of. Stair of what? Stair of 4 minus 2. Then let's say 9 minus 3, then 1, 1, and then I'll again write 4 minus 2. I hope we know how to expand it. So I'm expanding it, writing that result over here. I hope you don't get confused by that. So here the area is going to be 4 into 3, that's minus 12. Then 9 into 2, that's minus 18, but I need to take positive of it. I hope you're remembering going upward. Then 9 into 1 should be plus 9. Then 1 into minus 3 is minus 3, but negative of minus 3 will be plus 3. Then 1 into minus 2 will be minus 2. And 4 into 1 will be 4, but it should be minus 4 because I'm going upward. I'll take mod of it and I'll divide it by half. That will be the area of the triangle ABC. So what it turns out to be as, I hope we can calculate it very easily. See, 4 2 is 6, minus 12 minus 6 is minus 18. So plus 18 minus 18 is 0. So 9 plus 3 is 12. 12 upon 2 is 6. So that is the area of the triangle ABC. We don't need that area. This is the area of the triangle ABC 6. I need half of it. So half of 6 is going to be 3, and that's your answer to this particular question. Did you understand the whole approach? Did you understand this entire question with a great clarity that how can you have the maximum area over here? By using the concept of symmetry, you can prove such conclusion. How do I define the concept of locus now? How do you understand, or where do you understand this concept of locus? The idea is pretty simple in that case, students. Locus is a very simple, a very standard, very decent phenomena, which says that, let's say there is a point P, H comma K, which follows or fulfills a certain condition. I'm imposing certain restrictions on it, which means that P moves in such a way that its distance from a fixed point remains constant. So the fixed point, let's say I'm giving as 0 by 0, 0 comma 0. And P is a variable point because it is moving. It is a variable point because it is moving. And its distance is fixed, which is given by, let's say, A. So can I write the equation of P? Can I write the path of the equation, path which P follows, equation of the path which P follows? And that equation of the path is called locus of P. I hope you're able to digest my point very clearly here. So how do we solve such questions? What I'll do is, I'll say that, let's say the coordinates of P are H comma K. O is nothing but what? Origin. So we are told that P is moving in such a way that its distance from origin is A, always, always. So I'll say h comma k from 0 comma 0 is h minus 0 whole square plus k minus 0 whole square inside an under root is equal to A. So if I remove that under root, it will become A square. And ultimately, while solving questions based on locus, you remove h and k, you replace h and k by x and y. So this h square becomes x square, this k square becomes y square, and that is your a square. So this is the locus of this point P, which is nothing but the equation of a circle centered at origin having radius a. I hope you're understanding. Through locus, you solve questions like this. Now, let us seek more clarity on this particular concept, how to find the locus of a point, as we have already discussed the modus operandi, and let's get more clarity on that concept by looking at this question. JEE Mains in 2014 has asked this question, a very standard question. It says, locus of the point whose distance from this and this are in the ratio 5:4. So let's say this point is A for a while, let's say this point is B for a while, and the locus of a point which I'm trying to figure out, let's say that point is given by h comma k. So what am I told? In the question I'm given that the ratio of the distances of that point P from A and B is in the ratio 5:4. Is in the ratio 5:4. Did you get that? I hope there is no confusion on that front. Now, if that ratio is given, of course, I'm going to use the distance formula. So to avoid that under root sign, can I square both these sides? So when you square both these sides, it is going to be PA square by PB square, but on the right hand side, it will become 25 by 16. I hope there is no doubt on it. So what is going to be PA square? PA square is going to be h comma k from 2 comma 1. It is going to be h minus 2. I'll write it here. It is going to be h minus 2 whole square plus k minus 1 whole square. Do you get that? Divided by PB square. PB square means what? H comma k from 1 comma 3. So h comma k from 1 comma 3 will be h minus 1 whole square plus k minus 3 plus k minus 3 whole square is equal to what? 25 by 16. Did you get that part? I hope there is no confusion on that. Now let's try and simplify this. Let's see what do we get. So when I simplify this particular result, I'll get this numerator. I'll get h square plus k square from here. I hope you are understanding it very clearly. Now, I'll get minus 4h from here. So I'll write minus 4h here. I'll get minus 2k from here. I'm writing minus 2k here. I'll get 4 from here and 1 from here. So 4 plus 1 will make it 5. And that should be multiplied by this 16. I'm doing this cross multiplication is equal to 25 into the expansion of this part. I'm doing this cross multiplication along with the expansion in one step only. And that's also what you should also do. So here, h minus 1 whole square will give me h square. K minus 3 whole square will give me a k square. Now, this will give me minus 2h. This will give me minus 6k. I hope there is no confusion on that. And now, 1 plus 9 will give me plus 10. I hope there is no confusion on that front. Now, what am I going to do next is 25h square minus 16h square. So 25 minus 16 is clearly how much? This is 5 and this is 4, which is 9. So it is going to be 9h square. So here I'll be writing it as 9h square plus what do I have next? 25k square minus 16k square is going to be 9k square. So that is 9k square. Then what do I have next? I hope you can see it very clearly. Then I have 25 into 2, that is I'm writing here so that I don't forget, minus 50h. And then 16 into 4, that is 48, I believe, minus 48, which comes here becomes plus 48h. I hope I'm writing it correctly. 25 into 2 minus 50h. 16 into 4 is minus 48, but it becomes plus 48. So minus 50 plus 48 is minus 2h. So here I'll be getting a minus 2h from here. I hope there is no confusion on that. Now let's talk about the coefficient of k. From here, I get 25 into 6. So that I believe is 150 because double of 25 is 50. And then I need to do triple of it, so which is 150. So it should be minus 150k. And here it is 16 into 2, which is 32. But that is minus 32, which comes here becomes plus 32. I hope I'm writing it correctly. 25 into 6 minus 150 and 16 into 2 minus 32, which becomes plus 32. So 150 minus 30 is 120. I hope you're getting it. No confusion on that. 150 minus 30 is 120 and 120 minus 2 is 118. I hope we are going great. 150 minus 30 is 120 minus 2 is 118. That 2 of negative. So negative 118k. So it will be negative 118k. Correct me if I'm wrong, right? I may do some error here. Just keep looking at the solution. understand the approach at this stage. Calculation may go wrong, but I'm trying to stay as correct as possible, although nothing can happen to me even if I'm wrong in terms of calculation, because I'm not going to write the exam. But you should be more careful. The way I'm trying to be, right? Be alert, be attentive, because that is the part students take casually, and that's where they commit mistakes. So don't do that error. Stay alert, stay vigilant. That is the portion where students go light, because that's the part where you applied the logic. That's where you were on completely. But this is the moment where students lose focus and they commit such silly errors. And that's where they get the wrong answers. And of course, it is integer type. That's where you don't have options. Whatever answer you get, you will believe that that's correct. That's the problem. So here it will be 25 into 10, which is 250 here, which is 250. And here it is 16 into 5, which I need not tell, 80. And that is 250, and that is plus 80 becomes minus 80. 250 minus 80, 250 minus 50 is 200. 200 minus 30 is 170. So that is going to be plus 170. That is going to be plus 170 is equal to 0. So this is the locus. In this locus, all I'll do is I'll replace h and k by x and y. So when you replace h and k by x and y, it is 9x square. This is 9y square. This is minus 2x. This is minus 118y. This is plus 170 is equal to 0. Now the next part of this question I'm leaving up to you. You need to compare it with this. I hope you remember what is going to be a. A is going to be 9. So 9 is going to be the value of a. What is going to be b? B is going to be coefficient of y square, which is b, which is 9. Coefficient of xy, there is no xy, so c is going to be 0. Similarly, this and this are going to be, I think, what are they going to be? They should be DE. DE, yes. So that is your D, this is your E, and to verify your 170, they have given it. Because let's say if I take 9 common out of it, so it should have been 170 by 9. So I have not written it as 170 by 9, or I could have done something else with this equation, because this is an equation I could take common out of it anywhere like that. So they have kept one constant here to match it with your expression. So if you are comparing them directly, if you are saying that A is this, B is this, D is this, E is this, then you can compare, yes, that F is 170 only. So the ratio is 1:1 between their equation and your equation, so they can be compared directly. Otherwise, I would have to use proportionality there. So yes, f is going to be 170. There also they have given it as 170. Whatever values we are assuming are correct. And on the basis of these values, this calculation you can perform. I'm not going to do it. So what they do is they know that coordinate geometry is something which students love solving. Students enjoy doing. And it is very straightforward formula-based chapters. All of these chapters are where not much logical understanding is required. So how do they make questions more tricky or complicated? They give a lot of calculation. Now this calculation is completely useless. By making somebody do this, how are you assessing his brain? But they wanted to make the question lengthy because the question was easy. But they wanted to make the question lengthy. So how can they do it? They simply introduce such unnecessary calculation, which clearly does not justify or give any idea about a student's intelligence, right? A calculation, it's a simple calculation, right? Now, I'll talk about the straight line. So I think we are done with the chapter coordinate geometry, coordinate plane, or coordinate geometry, or the Cartesian system. Now we are moving towards the straight line, the second chapter. And then we have clubbed it as the one chapter, coordinate geometry with straight lines. I hope you are understanding it. So now we are moving towards the part of straight line. So before straight line, whatever basics were supposed to be covered, we have tried covering those. So now we'll be talking about the concept of straight line. Simply, I'll say that a straight line which we create by joining 2 points is a straight line. So let's say there is a line which I have created by joining 2 points is a straight line. Usually it is denoted by line, or in our language, we call it straight line. Did you get that? Now, when I say that, what is the meaning of gradient or slope of a line? So some people call it gradient and some books call it slope. So even if in the examination you see the word gradient, don't get confused. The meaning of the word gradient means the slope of the line only. Slope does not mean the inclination of the line with x-axis. No. Slope means 10 ratio of that inclination. And that inclination should also be measured by following a certain rule. What is that rule? Let's say this is that straight line AB. Now this straight line AB makes a lot of angles with the x-axis. This angle, this angle, this angle. Then which one we are supposed to choose? We'll go in the anti-clockwise direction and will hold to this angle only. So this will give me the inclination of this line. I'll not call this angle as the inclination. I'll not call this angle as the inclination. No, I'll call this anti-clockwise direction inclination. And the first time I meet this line will be called the inclination of this line. Let's call it theta. And if I take 10 ratio of this theta, then that 10 theta is said to be the slope of the line. Did you get that? So slope of the line means the 10 ratio of the inclination of the line with positive x-axis measured in the direction of anti-clockwise movement. Did you get that? I hope there is no confusion on that. And through this diagram, you have gotten that confusion cleared that this is neither this angle nor this. This is simply this angle. What is it? Line, positive x-axis, anti-clockwise direction. That's it. Will you remember that? So when you take 10 of that angle, that is called the slope of the line. I hope there is no confusion on that. You are getting a great clarity on that. Now, moving ahead towards this part, we have discussed the slope. Now, slope means what? Slope gives you a lot of details about a line. Slope of a line is not the angle as we have discussed. It is the tangent of that angle. If a line is parallel to x-axis, we know its slope is going to be 0 because theta is going to be 0. I hope I need not tell you this. If the line is parallel to x-axis, its inclination with x-axis is going to be no angle is there. So the inclination is 0. So tan 0 is 0. What if the line is parallel to y-axis? I hope you know that if a line is parallel to y-axis, it makes 90-degree angle with the x-axis. And if the angle is 90 degree, which means tan 90, which is not defined. So slope will be not defined. But here in coordinate geometry, while treating infinity, while dealing with infinity or slope as infinity, I'll write or refer it as 1 by 0. I'll deliberately do it. You will understand why. Now, moving ahead towards the next part, whenever somebody says that a line makes equal intercept with both the axes, if a line makes equal intercept with both the axes. So these are the two possibilities. Or rather, there are four possibilities. The first possibility is the line is in the first quadrant. It makes equal intercept means what? It will make equal angles here. So the slope of the line could be tan 135, which is minus 1. Or the other possibility could be like this, that the line is making equal intercept here and here, which means the line is making equal angle with the x-axis and y-axis, which means the inclination here is 45, which means the slope could be tan 45, which is 1. So whenever somebody says that the line makes equal intercept with the x-axis and y-axis, then the slope of the line could be either plus 1 or minus 1. I hope you will remember these facts which I'm giving you as general results. Now moving ahead towards the next part here. Let's say there are 2 points on the Cartesian plane. I'll just draw them like this. So there is a line and there are 2 points on this Cartesian plane. One of the point is x1 comma y1. And the other point is, let's say, x2 comma y2. So if I wish to figure out the slope of this line, it is always given by y2 minus y1 upon x2 minus x1 upon x2 minus x1. This is something we have already discussed while discussing differentiability as well. What is the geometrical meaning of differentiability? The slope of the tangent drawn to a curve at a point. That's exactly what we have done there as well. I hope you remember f of x plus delta x minus f of x upon x plus delta x minus x. Do you remember that? The delta x approaching 0, dy by dx. That's exactly what this is. I hope you must be able to collect it with that result, right? Now, whenever x1 is equals to x2, which means the line is parallel to the y-axis, in that case, the slope will be not defined, that is infinity, because angle will be pi by 2. I hope I need not give any clarity on that front. Moving ahead, there are some more conclusions based on slope. What are they? I hope you understand that if the lines are parallel, then their slopes are going to be equal. Why? Because let's say these are the two lines. If I'm dealing with two straight lines like this line and this line, if both of them are parallel, do you not think that their angle or their inclination with the positive x-axis will be same? Which means their tan theta will be same, which means their slopes will be same. I hope you're understanding it. Similarly, this is a very crucial result. This is the third approach through which you can prove that 3 points are collinear. One of the approaches was distance formula, second was triangle area formula, third is slope. What I'm trying to make you understand here is, let's say there are 3 points. There are 3 points like this. There is a point A, there is a point B, and there is a point C. And I wish to prove that they are collinear, or I wish to check that they are collinear. The easiest method will be slopes. Why? Because it involves lesser calculation. How? Please understand, the slope of AB, the slope of BC, and the slope of AC will be same. So you take any two and you'll get the answer. Did you get my point? Some of you might say, sir, this is a possibility that AB and BC are parallel. Yes, I would agree that AB and BC could be parallel, but how can you have B at two places? You cannot have B here and here at both the places. B has to be only one. So I need to lift it up from here and join it here. So that will be C. Did you get that part? So I hope you are understanding. By using this concept of slope as well, you can prove that the 3 points are collinear whenever asked or given as per the requirement of the question. I hope we can move ahead. We can go ahead with the next part. This is another chunk which is proved by 10 alpha plus beta, which is 10 alpha plus 10 beta upon 1 minus 10 alpha 10 beta. That formula I'll use here to find the angle between two lines. So let's say there are two lines. This line has a slope m1, this line has a slope m2, and there is an acute angle given by these two lines. So that acute angle theta is given by the formula tan inverse m1 minus m2 upon 1 plus m1 m2, and I need to put a mod over it because this is an acute angle. For acute angle, tan theta is positive. Between 0 to 90, tan theta is positive. I hope you remember that. So that's why we are putting a mod over it. The proof you can remember, the proof you can recall from the chapter inverse trigonometric function. That's a very standard and a basic proof. My conclusion here is that you should remember this formula. And from this formula, you derive or you come up to two more conclusions. What are those conclusions? First conclusion, if two lines are parallel, then tan theta will be 0 because they don't have any angle between them. They are parallel, which means the numerator will be 0, which means m1 will be equal to m2, as we have already discussed. The second conclusion, which is very widely, very prominently and used at a lot of places, is this, that if two lines are perpendicular, if two lines are perpendicular, then of course the angle between them going to be 90. So this is going to be 1090, infinity 1 upon 0, which means the denominator should be 0 if the lines are perpendicular. If m1 m2 plus 1 is 0, would I not say that m1 m2 should be equal to minus 1? So whenever two lines are perpendicular, the product of their slopes is minus 1. Always remember this. Always remember this. Not just that, remember this result as well. Let's say one of the lines is having slope, let's say 3. So the other line will be having the slope as negative reciprocal of it if these two lines are perpendicular. This is how you should remember it. I hope you won't forget this particular result. Now we'll talk about if the lines are parallel to the axis, what will be their equations. Idea is pretty simple, nothing much is needed to be done. For example, this is our Cartesian plane. These are the x-axis and y-axis, and this is a line. Of course, this is a line which is passing through which point? This is a line which is passing through a point 3, 0 on the x-axis. Now you must understand that all the points which will lie on this line will have the same coordinates. For example, 3, 1. For example, 3, 2. For example, 3, 3. So all these points will have the same x coordinate. And of course, the equation of the line can be given by x is equals to 3, because this is going to be x is equals to 3 because all the points on this line will have their x coordinate to be 3. I hope you're understanding it very clearly. For example, if there are x-axis and y-axis like this, and for example, there is a line which is parallel to the x-axis. Now what will be here? Let's say this is a point which is 0, let's say minus 2. So all the points on this line will have their y coordinate to be minus 2. I hope you're understanding why. This will be, let's say 1, minus 2 and so on. So the equation of this line, which is parallel to x-axis, is given by y is equals to minus 2. Not just that, if I were to ask you the equation of y-axis, it will be x is equal to 0. If I were to ask you the equation of x-axis, it will be y is equal to 0. Did you get that conclusion? Why? I hope you're able to make a lot of sense out of it. Now, moving ahead towards the next part, intercepts of a line on the axis. I'll say a very simple strategy need to be adopted. Let's say there is a straight line which is having equation 2x plus 3y plus, let's say, 6 is equal to 0. And if I were to find out its intercepts on the x-axis and y-axis, so we know wherever this line intersects the x-axis and y-axis, at those points, y coordinate and x coordinate will be 0 respectively. For example, at x-axis, what will happen? Sir, if this line intersects the x-axis, at that point, y coordinate will be 0. So if I replace y by 0 as 3 into 0 is 0, 2x plus 6 is equal to 0. So 2x is equal to minus 6. So x is going to be minus 3. So x-intercept is going to be minus 3, 0. What about its y-intercept? Sir, for y-intercept, this is, of course, it is going to be the x-intercept. That means the point where this line intersects the x-axis. X-intercept will be the length. So here, if I talk about the y-intercept, basically the point where this line intersects the y-axis, at that point, x-coordinate will be 0. So if I put 0 here in place of x, this will be 3y plus 6 is equal to 0, which means y is equal to minus 6 by 3, which is going to be minus 2. So did you understand that this line will be passing through, of course, x-axis and y-axis, from or through these points -3, 0 and 0, -2. I hope you are understanding. This will be -3, 0 and this point will be 0, -2. And if I join these 2 points, I'll have my straight line getting created like this. So if somebody asks, what about the x-intercept? Then this over here will be called the x-intercept and this length over here will be called the y-intercept. Did you get that part? That exactly is what I'm trying to give you here clarity upon. So if a line intersects the x-axis at a point, so that point of intersection from origin, that distance will be called the x-intercept. The line's point of intersection with y-axis, that point's distance from origin is called the y-intercept. That's exactly what we have discussed or discovered over here. Now, of course, as per the quadrants, we need not explore that part right now at this stage. Don't get confused with that. I'll straight away now begin with the part where we'll be discussing the slope-intercept form of a straight line. What does it mean? It means, for example, there is a straight line. There is a straight line, somewhat like this. Let's say this is a straight line. And I am given two things. Which two things, students? Let's say I am given this thing that here, this line makes an intercept of 0, c on the y-axis. Before I explain this part, let me get back to the part. I hope you are very much convinced by the fact that whenever a linear equation in two variable is given, that is ax plus by plus c is equal to 0, it always represents a straight line on the coordinate plane. I hope you understand this. Now, if I get back to this conclusion, here what are we seeing is that there is a straight line and it is making an intercept on the y-axis as 0, c. That means the line intersects the y-axis at 0, c. C, I hope you'll remember, could be negative or positive depending on the part where the y-axis is intersected. If it is above the origin, it will be plus c. I mean, the value of c will be positive. If it is below the origin, it will be, the value of the c will be negative. So that is 0, c, the y-intercept, the point where the line intersects the y-axis. Again, if its slope is known, let's say I know its inclination with the positive x-axis, then I hope we can work out its slope, which is given by tan theta. So I can figure out its slope, let's say m, which is given by tan theta. In that case, the equation of the line is always given by y is equals to mx plus c. What is m here, students? We all know that m is going to be the slope of the line, which is tan theta. And what is c? The intercept, 0, c. That c is this c. Always remember, this is the slope-intercept form of a straight line. I hope there is no confusion on that front. If I were to ask you that there is a straight line which goes like this, it passes through the point 0, -2 and it makes an angle 30 degree with the positive x-axis. Can you help me with its equation? You will say, sir, its slope is nothing but tan 30. We know the value of tan 30. Tan 30 is basically nothing but 1 by √3. Its intercept is 0, -2. So c is going to be -2. So the equation of the line is given by y is equals to mx plus c. And there you will say that y is equals to mx. What is m? M is 1 by √3 times x plus c. C is -2. That's the equation of the line. Did you get that part? A very simple, straightforward conclusion it is. No confusion on that, I believe so. Moving ahead with the next conclusion, next form. Some general results should be understood by you all. If the line is passing through 0, which means it is intersecting the y-axis at origin, which means the value of c will be 0. So whenever the line passes through 0, the equation of the line will be y is equals to mx, because there is no intercept here. I hope you understood this reason as well. The equation of any line could be taken as y is equals to mx plus c, where m is the slope and c should be the y-intercept. Along with this, yes, if the line is parallel to x-axis, theta will be 0, as we have already discussed. Its equation is going to be y is equal to c. If the line is parallel to the y-axis, theta will be 90. In that case, its equation will be x is equal to a constant. That constant will be the point from where it is passing through. I hope you remember, as we have already discussed in the previous slides, right? Next is the point slope form of a line. What do I mean by that? For example, let's say there is a straight line. There is a straight line. This is, let's say, positive x-axis, and this is its inclination. And if I know its inclination, I hope I know its slope, which is given by tan theta. One more thing I'm aware of, which is, let's say, a point x1, y1 on this line. So I know two things, a point on the line and its inclination with the positive axis, which means positive x-axis, which means its slope. So if I know these two things, I can write its equation by following a very simple formula, y minus y1 upon x minus x1 is equals to m. Because y minus y1 upon x minus x1 is nothing but what? Its slope, which is m. So if I rewrite it, it will give me y minus y1 is equals to mx minus x1. This is called point slope form of a straight line. So if you know a point lying on the line, if you know its slope, then also you can write its equation. Did you get that part? I hope there is no confusion on that. Now, if you have understood that result, let me go ahead with some more conclusions, right? After this is 2-point form of a line. What does it mean? Let's say there is a line. And I am not told a lot of details about this line, but what I know is that this line passes through 2 points, x1 comma y1 and x2 comma y2. Let's say this line passes through these 2 points, x1 comma y1 and x2 comma y2. Do I still have the opportunity to write the equation of the line? Yes, we do have. What is that? Please understand, I know that yes, the equation of the line or the slope of the line can be given by y minus y1 upon x minus x1, where x and y are the variable points lying on the line. So the slope in other form can be written as y2 minus y1 upon x2 minus x1. So as per a logic, this could be the slope. As per other logic, this could also be the slope. These are the slopes of the same line, which means the slopes should be equal. And if the slopes are equal, this is how you are forming a 2-point form of a straight line. The equation in 2-point form. I hope you are understanding and learning these results. For example, if you didn't get that part, I'll try and make you understand with one example. Let's say this is a line, and on this line 2 points lie. One of the points is 2 comma 4, other point is, let's say, 1 comma minus 3. If I were to write the equation of the line, what I'll do is I'll simply say y minus y1, which is, let's say, y minus 4 upon x minus x1 is x minus 2. Then y2 minus y1, so 4 minus minus 3 is 7 upon x2 minus x1, so 2 minus 1 is 1. I hope we are going great. You just need to simplify this, and I hope you all are realizing after cross multiplication and simplification, you'll get a linear equation in 2 variables, which will again represent a straight line, which is nothing but this, which contains these two points on it. I hope you are able to make a great sense, able to generate a complete greater sense on this particular part. Let's talk about the intercept form of a straight line. I hope you must remember, let's say there is a straight line and there are x-axis and y-axis. So let's say x-axis and y-axis intersect the, I'm really sorry, the straight line intersects the x-axis and y-axis at these 2 points. Let's say x-axis is intersected at a comma 0, y-axis is intersected at 0 comma b. Now, of course, it can be anywhere. It can be in the 3rd quadrant, 1st quadrant, 4th quadrant, wherever it is. Accordingly, a comma 0 and 0 comma b's value will be decided whether it will be either it will be positive, negative, or both, something like that only. Now, what you need to understand is in that case also you have these 2 points. So with 2-point form, you can write the equation of the straight line. But the advantage here is that you need not put that much effort. Here you can directly write the equation of the straight line as x upon the x-intercept plus y upon the y-intercept is equal to 1. This is also nothing but the equation of the straight line. If you simplify this, you'll get a result, which you will get after simplification of this as well, through which you can write the 2-point form of a straight line. So if 0 comma b and a comma 0 are 2 points which lie on a line, 2-point form of a line can be formed. Through that also you'll get the same result which you'll get by this. So I hope you'll understand this intercept form of a straight line. All what we have discussed so far, let us try and revise with this example. Let us have a clarity on the concept of straight lines through this particular example. What does it say? Let's look at the question first of all. It says area of the triangle formed by a straight line with coordinate axis be 48 square units. So there is a straight line, and this straight line makes a triangle with the coordinate axis, x-axis and y-axis, and that triangle's area is given to be 48. Brilliant, that's great. But the problem with this straight line is that it's y, the coefficient of y and the constant term are not given. Okay, that's great. Now, if the perpendicular drawn from origin to the line makes an angle 45 degree with the positive x-axis. Now, that's a very interesting part. You should read and understand this particular part. A lot of conclusions verbally can be drawn from this particular line, if you are understanding. First one, perpendicular drawn from origin to the line makes an angle 45 degree with the positive x-axis. So there is a line which makes 45 degree angle with the positive x-axis. Do you remember that? Do you remember that? 45 degree, 10, 45, 1. So the slope is 1. So I hope you're realizing I can write the equation of the line from there only. This line at least. Then you are asked the value of b square plus c square. I'll just draw the entire case and then we'll start solving it. Okay, so I'll begin with one of the possibilities because not very much greater clarity is given to us. So I'll simply take the benefit of doubt. What do I mean by taking the benefit of doubt? Let's say there is a straight line. This is that straight line with straight line L. So this is the straight line x plus by plus c is equal to 0. Now, if I were to ask you that this straight line is intersecting x-axis and y-axis at 2 points, so these are those 2 points, this point and this point. So this is that triangle, right? This, let's say O, A and B. This is that triangle. So can I find the area of this triangle? We all can very easily. But before that, can you help me with OA? What will be OA? If I could find the coordinates of A, I hope you are realizing at A, y coordinate will be 0. So if I replace y by 0, the coordinates of x are minus c. So this distance is going to be mod of minus c, which can be treated as mod c. Did you get that? Similarly, what can you say about the y-intercept of this line? Coordinates of B. So B will have x coordinate as 0. So if I replace x by 0, y coordinate will be minus c upon B. So if I talk about this distance here, which is OB basically, so OB distance is going to be mod C upon B. Did you get that result? I hope there is no confusion on that. Now, can you help me in writing the area of this triangle, half base into height, because this is a right angled triangle OAB. So if I were to write the area of the triangle OAB, it is going to be half base into height. So half is half. What is base? Base is mod C and height is mod C by B. So it should be mod C square by mod B. And this area we are given as 48. I hope you are getting it very clearly. There is no confusion on it. I hope you are comfortably understanding this result. So from here, I am reaching to a conclusion that C square is equals to 48 when double gives you, I think, 96. I hope there is no confusion on that. So this is 96 times mod B. Don't forget it is not B, it is modulus of B. Okay. Now, what I do next is, and that's the part where I was mentioning that take care of this area formula, because students usually what they do is they take it as C, they take it as C by B and they simply multiply it and they forget taking care of this fact that there could be other possibility as well. So with that, keeping that thing in mind, I'm introducing this mod B here. I'm not keeping it as just B. Now, another part which we were told was this, that there is another straight line from origin which is a perpendicular on this line. So there is another straight line which we have drawn from the origin and it happens to be a perpendicular on this line. And this line which is drawn from the origin makes an angle 45 degree with the positive x-axis. So I hope this line's equation is very simple. It is going to be y is equals to mx plus c. But what is c? Since this is passing from origin, c is 0. So this is y is equals to mx. And what is m? 1045, which is 1. So this line will have its equation. This line will have its equation as y is equals to x, which I hope most of you are aware of. Now, what are we told? We are told that the perpendicular drawn from the origin to the line L makes an angle of 45 degree with the positive x-axis. All right, that's great. Now, what is the advantage of this? What is the advantage of this? Let me look at the question now. We are told the area of the triangle formed by the straight line x plus by plus c with coordinate axis is 48. This is what we have concluded so far. The additional part was this, that this is perpendicular over here. I'll use the condition for perpendicularity. Now there comes a very interesting result. What is that? See, if I know the slope of this line, which is y is equals to mx plus c, the line is y is equals to x only. So the slope of this line is 1. And if this line L is perpendicular on this line, then will I not say its reciprocal will be negative reciprocal of 1? Its slope will be negative reciprocal of 1. Because if the slope of this line is 1, the slope of this line will be minus 1 because they are perpendicular. The product should be minus 1. Do you remember that? The product of the slopes. So this line has a slope minus 1. But what is the slope of this line as per our understanding? So as per our understanding, the line is x plus by plus c is equal to 0. From here, can I write it as by is equals to minus x minus c? I hope you are understanding it. So from here, can I say that y is equal to minus 1 by b whole times x minus c by b? All I have done is I have tried writing it in the form of y is equals to mx plus c. Did you see it? X plus by plus c. So by was minus x minus c. So y was minus 1 by b times x minus c by b. So if I compare it with the point slope form, do you not agree that this will be the slope of the line L? So according to us, the slope of the line L, is going to be minus 1 by B. I hope you can see that there. But as per their understanding, the slope of the line L is given as minus 1. The slope of the line L is given as minus 1. So I hope from here we can conclude that the value of B is 1. The value of B is 1. I hope there is no doubt on that. So if the value of B is found to be 1, can you not find the value of C? Because C was 96 times modulus of B. If B is 1, mod of B is also 1. So C square will be 96 only. C square is 96 only. So we know the value of C square, we know the value of B. So C square plus B square will be 96 plus 1, which is 97. Did you understand the entire explanation? Did you understand the whole question? Are you able to make a great sense out of this particular chapter now, that how should you deal with questions based on straight lines? I hope there is no confusion on that and you're getting a very good clarity of this particular chapter. Moving ahead with the next part, the normal form. That's the most interesting form and that is what you should pay a lot of attention to. How do we deal with this? Let's have a look at that. With this form, there are a lot of things. What all things are there? Let's have a look at that particular part. First of all, please understand, let's say there is a straight line. So let's say this is that straight line AB. Now, two things if you are aware of, then you will be able to write the normal form. Which two things? Let's say I drop a perpendicular on this line from origin. I drop a perpendicular on this line from origin. So let's say I know two things, the length of the perpendicular and the angle made by this perpendicular with the positive x-axis. If I know these two things, I can say a lot about the normal form of a straight line. Let's study everything in detail form it one after another. First of all, I hope this conclusion remains very clear that there will be a straight line, but nothing related to that straight line is given to us. Rather, what is given to us is that a perpendicular from origin is dropped on that line. So that perpendicular, the angle it makes with the positive x-axis is given and its length. So this perpendicular's length, or rather in a simple language, the perpendicular distance of the line from the origin is given. So two things are given. Will you be able to write the equation of the line? Yes. I'll tell the direct formula as well, which is nothing but x cos alpha plus y sin alpha is equals to p, where alpha is the angle made by that normal with the positive x-axis in the anti-clockwise direction only, and p is that perpendicular distance. But where did it come from? That is which is very interesting. But of course, we'll go into its discussion of that where did it come from. But before that, please understand, this is the normal form. What is alpha here? Alpha is the angle made by that normal. Which normal? The normal which we have dropped, the perpendicular which we have dropped from origin on the line. What is alpha? I hope you are understanding it. What is p? That length of the normal. So from origin, we are dropping a perpendicular on the line. The length of that perpendicular is the length or the value of p. If you know alpha and p, then also you can define a line uniquely. But how is this formula coming from? Or where is this formula coming from? That is what we are more interested in. So simple logic is there. Before I could share simple logic, let me give you more clarity about this part, that how do you deal with alpha, how do you deal with p. So there is something related to alpha which you should remember, that alpha is always an angle which you measure in the anti-clockwise direction. So unlike gradient, alpha is something different. I hope you remember that. Let's say if the line happens to lie in the second quadrant, let me see whether we have this figure or not. So let's say if the line happens to lie in the second quadrant, let's say this is the line. In that case, I hope I need not tell you, in that case, this will be the value of alpha. Did you get that? Because this will be that perpendicular. Let's say if the line lies in the third quadrant, or passes through the third quadrant like this. So in that case, let's say if I'm dropping a perpendicular, then you don't say this will be alpha, rather this angle here will be the alpha. Always measure it anti-clockwise direction from the positive x-axis. For example, let's say if here we have the line passing through the fourth quadrant like this. In that case, let's say I've dropped a perpendicular like this. Then also this will be the measurement of this angle alpha. So alpha will first of all tell you that from which quadrant is this line passing. Intercepts, it will give you more clarity about the intercepts. Second thing, the length of that perpendicular. So this length over here, I hope you're getting this length over here. Or you may say this length over here, or you may say this length over here. This is the value of p. Did you get that part here very clearly? So if I am aware of these two things, I can define a line uniquely. That's my part here. Now, how did it come from? The idea is really simple. First of all, please understand. It has its own very decent, very simple proof. I'll directly give you the result here. Let's say we have our Cartesian system, x-axis and y-axis like this, and we have our straight line, let's say, going like this. So this is the straight line, and on this straight line I'm dropping a perpendicular like this. So this is the perpendicular, right? And this perpendicular makes a positive angle alpha with the positive x-axis. I hope there is no confusion on it. Now if this is the alpha, can you help me with this particular angle? I hope I need not tell you that if this triangle is a right angle triangle, this is alpha, this is 90, this will be 90 minus alpha. I hope there is no doubt on that. Now this angle over here will be the complementary of this angle. Do you all agree with this for me? So this angle here will be the complementary of it, which will be nothing but what? 180 minus 90 minus alpha. So through this, I'll get the slope of this line because I got the inclination. And once you have this theta of this line, then I can write its slope. So we have found the slope. What about its y-intercept? Because if we have the slope, I think from here I can find tan theta, which means I can have the value of m. So I think I have gotten the m. Now, once you have gotten the m, can you find its y-intercept? Because the moment I crack its y-intercept, I think I will be able to write its equation, because equation of the line in slope intercept form is given by y is equals to mx plus c. Do you remember that? So we have cracked m. I hope you know, because we know alpha. So I think with alpha we can crack theta, and if we have cracked the theta, we know tan theta, we know the slope, which means we have m. How do we crack c? See, understand. This length we already know. This length is what we are given as p. Now, if this was alpha, do you not agree that this will be 90 minus 90? This will also be alpha. So if in this triangle, if I know this is alpha, this is p, can I not put any comment about this? We know an angle, we know a side in a right angle triangle. So by using basic trigonometry, can I not put my comment on this hypotenuse? Because we know something about perpendicular, we want to know something about the hypotenuse, but what we know is the angle as well. So I hope sine alpha will help you there. So with that, you can get this value in terms of p, which means you can crack c as well. Once you have cracked m and c, will you not be able to write the equation of the line? I hope you're understanding this. I'm not giving you the complete derivation, but I'm sharing the approach. And if you do understand this particular approach, from that derivation only, you will reach to this conclusion: x cos alpha plus y sin alpha is equals to p in its most simplified form. So I hope you'll remember this conclusion. IIT again is in love with this particular result. Do remember this particular conclusion, that whenever a line is given to us, but nothing much related to that line is given, but rather what is given to us is that a perpendicular from origin is dropped on this line, the length of that normal is given, and that normal, what angle this normal makes with the positive x-axis in the anti-clockwise direction, that is also given. If these two things are given, based on that alpha and p, I can write the equation of the line as x cos alpha plus y sin alpha is equal to p. Please, please, please remember that. I hope there is no confusion on that. If I could simply give you an example, I'll very, very directly give you an example, a very straightforward example. Let's say there is this coordinate axis, x-axis and y-axis, and there is a straight line. What we know is that this straight line, on this straight line, I'm dropping a perpendicular from origin, and that angle, that perpendicular makes a 30-degree angle here with the positive x-axis in the anti-clockwise direction, and the length of that perpendicular is, let's say, 3. Can we write the equation of the line? Yes. How? I hope you must realize that this 3 is nothing but what? P. What is this 30 degree? This is nothing but what? This is alpha over here. So I hope we have everything, because how do we write the equation of the line? X cos alpha plus y sin alpha is equals to p. This is going to be x cos 30 plus y sin 30 is equal to p. What is p? P is 3. I hope you can simplify this. You can find the value of cos 30 sin 30, and then you can simplify this. My point is, from this 3 and 30, you need not go to the slope of the line and then the y-intercept and then write the equation. No, don't do that always. Use this result and avail the benefit of this result, and by doing so, you can write the equation of the line within seconds. But of course, you should remember that where did it come from? You should have that algorithm in mind, because even if you forget that formula, you should have that approach with you, because in the examination, let's say they don't ask a direct question based on that formula, but something related to this result only, then you should be able to derive that. And we have discussed the approach as well. I hope you remember. Now, moving ahead towards the next part was very simple here. Of course, coefficient of x square plus coefficient of y square is 1. We all know that. This is something which we have already discussed in vectors in 3D, direction, cosines, and direction ratios. Let's not get confused by that discussion over here. But let's say I am given a standard form, let's say ax plus by plus c is equal to 0. This clearly looks like, or it is indeed, a linear equation with two variables x and y, in x and y. So this clearly represents a straight line where a, b, c are arbitrary constants. Now, can I convert this equation into normal form? The idea is really simple, students. I'll share all the different conversions. First of all, I'll begin with this conversion where I'll say that how can we convert it into, let me just check the heading, standard form. Yes. So the first subheading is reduction of this equation into, or conversion of this equation into, slope intercept form. Trust me, the idea is really simple. Don't do much. Or rather, instead of giving you this example, I'll take a better example. Let's say I have a line 2x plus 3y minus 6 is equal to 0. This is the standard form. Let's say I'm asked to convert it into slope form. What will I do? I'll simply write it like this. 3y is equal to minus 2x plus 6. I have taken this x and constant term on the other side. I'll divide all the sides, both the sides, by 3. So I'll have y is equal to minus 2 by 3 times x plus 6 by 3, which is 2. Are you not able to relate it with the simple standard form of slope intercept form of a straight line, y is equals to mx plus c? So by comparing the coefficients, one is with y, there is also one with y. So I think the value of m is going to be minus 2 by 3 and the y intercept is going to be 2. Did you understand this whole part very clearly? I hope there is no confusion on that. You are very clearly able to understand that how are we converting this standard form into slope intercept form. I hope you are getting this very clearly. With that, you must also be able to understand one more result. Let's say there is a straight line, somewhat like ax plus by plus c is equals to 0. If I convert it into slope intercept form, what will I say? I'll say, sir, y is going to be ax plus c goes there and b divides it. So it will be minus a by b times x minus c by b. What you must realize is this particular result, minus a by b. This is always going to be the, the slope of your straight line. What do I mean by that? The coefficient of x and the coefficient of y, take their negative ratio, minus a upon b. That will always give you the slope of the line. For example, if the equation of the straight line is 2x plus 4y minus 6 is equal to 0. Can you find its slope without even converting it into slope intercept form? Yes. 2 by 4, that is 1 by 2, take its negative, it is the slope of the line. Did you get that? Please remember this. These are some standard basic results which you should have with you so that you can save a lot of time if you apply such learnings with more efficacy and effectiveness. That's exactly what we are given over here as we have discussed. I hope you remember. Let's say we are given two straight lines. Let's say first one of the lines is a1x plus b1y plus c1 is equal to 0. The second straight line is a2x plus b2y plus c2 is equal to 0. So when you deal with different methods of solving two linear equations in two variables, we know substitution or elimination. Then we had discussed some results, some crucial results. For example, the lines could be intersecting if a1 upon a2 is not equal to b1 upon b2. Do you remember that? But if a1 upon a2 and b1 upon b2 are equal, then there are two possibilities. Then first possibility is if a1 upon a2 and b1 upon b2 is equal, but if it is not equal to c1 upon c2, then we said the lines could be parallel. The lines are definitely parallel. But if even c1 and c2 are also equal, that is a1 upon a2, b1 upon b2 and c1 upon c2, all three ratios are equal, then we say the lines coincide, which means there is only one line. There is no other line. That other line is also lying on that same line. Basically, it is the same line. I hope you're understanding it. So that is the scenario which we have already discussed, I think, so far previously as well. Now look at this question. A lot of students have wasted a lot of time in solving this question by using the conventional method. But if you paid a little bit attention to this particular question with more observation skills, with a better observation skills, you could crack it in seconds. How do we do that? Let's have a look at that part. First of all, let's understand the question. Let's understand the language of the question. Of course, before I start doing this question, I request you also attempt this. And when you try this, give it a try and try to look for some clues. Don't straight away jump with this idea that whatever is given, I need to just start applying that. Look at the data, look at the values, look at the numbers, just analyze it well and try to draw it more properly. And then you might be able to come up with some simple 10-second solution only to such big or huge question asked by JEE Mains in 2025 based on which we have just discussed in the last slide. I repeat, what you should remember is that don't straight away start following what you are told by this question. Look at the data. It says a line passes through origin. Okay, great. And makes equal angles with the positive coordinates axis. Great. I think you are getting a lot of clarity by this particular part. Now, it intersects this line, and this line, where P is positive, of course, at the points A and B respectively. And we are told that AB is 9 by root 2. Okay, that's great. So we are told, okay, I'll talk about the other part later, but let me now put my focus on some other things. For example, look at the line L1 and L2. Do you not remember something we have just discussed? L1 and L2. Do you remember? 2 upon 4, 1 by 2, 1 by 2, 1 by 2. And this we don't know. But what I know is that these two lines are different. But the ratio of their coefficients of x and y is same. A1 upon A2 is equal to B1 upon B2. And in that case, what do we know? That the lines must be parallel. Do you remember that? So in that case, I'll come up to a conclusion saying or stating that, sir, yes, I can draw a very interesting, very good conclusion, which says that, let's say, if this is the line L1, if this is the line L1, which is 2x plus y plus 6 is equal to 0, then there is other line which is parallel to L1. I hope I've drawn a parallel line. Yes, it looks like a parallel one. So there we have L2, right? What is L2? L2 is given as 4x plus 2y minus p. So this is given as 4x plus 2y minus p is equal to 0. This is 4x plus 2y minus p, where p is positive. We'll remember that. Now, what is special in this question here? Now, what are we told? That our line passes through origin and makes equal angles with the positive directions, positive coordinate axis. I hope you're realizing 45 degree. Now, it intersects the line L1 and L2 at the points A and B respectively. So there is a line which intersects these two lines at A and B respectively. So let's say these are A and B, right? So line L1 is intersected at A, line L2 is intersected at B. And we are told that AB is 9 by root 2. So this length AB is 9 by root 2. Great, that's brilliant. What are we told additionally? That the foot of the perpendicular from A on the line L2 is M. So from A, I am dropping an altitude, I'm dropping a perpendicular. So I hope this is how the perpendicular looks like. And this foot is N, right? Then what are we asked? We are asked AM upon BM. What are we asked? We are asked AM upon BM. Did you get that part? I hope there is no confusion on that front. Now, let's say I somehow figure out this angle. How? I don't know. But what am I asked? AM upon BM. Do you not think that when somebody asks you the value of AM upon BM, forget all what you have studied so far, just go into the 10th standard, and do you not think that this is simply a question on perpendicular upon base, AM upon BM? And what is AM upon BM? We all know AM upon BM is nothing but 10 theta, where I'm calling this angle to be theta, I hope there is no confusion on that. But what is this theta? So this theta is the angle between this line and this line. This theta here is nothing but the angle between this line and this line. Do you get that? Do you understand that? I repeat my part very clearly. Please understand this part. This AB is given to be 9 root 2, which we may not utilize later. But as of now, what I know is we need to work upon AM upon BM. What is AM? Perpendicular. BM is base. So perpendicular upon base is what we need to put our comment upon. That we know can be worked out with the help of 10 theta. But now other catch here is that how do we find 10 theta? Okay, let's forget 10. Can we find theta? What is theta? The theta is the angle between this line and this line. Okay, so can you help me with the slope of this line? I think slope of line L2 is given by, I hope you remember, A upon B, the negative of A upon B, which is negative of 4 by 2, which is minus 2. So the slope of line 2 is minus 2. The same slope will be held by L1 as well, because they are parallel. They should have the same slope. Can I say something about this line? Yes. This line passes through origin and it makes equal angles with the positive coordinate axis. Do you not think that this line can be taken as y is equals to x? This line is nothing but what? This line is basically y is equals to x. This line is y is equals to x, which means its slope is going to be 1. So I know the slope of this line, I know the slope of this line, and by knowing the slope of these lines, can I find the angle between these lines? I think that will be the answer to this question. What I'm trying to make you understand is, I hope you remember that tan theta between these two lines is given by m1 minus m2 upon 1 plus m1 m2. Do you remember that formula? So what does that formula say? That formula says m1 minus m2. So 1 minus minus 2. That is clearly how much? 1 minus minus 2 is, I'm really sorry, 1 minus minus 2 is basically 1 plus 2, which is 3. Divided by, I hope you remember, m1 minus m2 upon 1 plus m1 m2. So 1 plus m1 m2. I hope you remember this. So 1 plus m1 m2. So m1 is 1, m2 is minus 2. So that's minus 2. So 1 minus 2 is minus 1. This is 3 upon minus 1, which gives you 3. So what is the value of tan theta? The value of tan theta is 3. The value of tan theta is 3, which we are given in option D. Did we really need to use this data? No, not at all. Not at all. Absolutely not. So did you understand this entire solution? I hope you are comfortably getting this conclusion in this result without any doubt or hesitation or confusion. Are you understanding this particular result? Any doubt, any confusion on that? I hope you are comfortably getting this idea that in this particular question, not much was needed to be done. And a lot of students ended up in, wasting a lot of time in doing a lot of other things, feet of the perpendicular, a lot of other things, Pythagoras, and they did a lot of other things. They used a lot of very in-depth concepts which were not needed to be used in this particular question. If you remember this basic concept here, can we move ahead from here? I hope you have gotten a great clarity on this front. Moving ahead towards the next part of this here, how do we convert this standard form into intercept form? That is even more easy. How do we do it? I'll try and tell you a different example. So let's say, so this is equation 2x plus 3y minus, let's say, 18 is equal to 0. That's the equation of a straight line. How do you convert it into the intercept form? All you do is take that 18 outside. So 2x plus 3y is equal to 18. Divide both the sides by 18. What do I get? X by 2 by 18 is 9. 3 by 18 is 6, I think, and 18 by 18 is 1. So this is x by 9 plus y by 6 is equal to 1. And I hope you can see this is the conversion of standard form to intercept form. So this line will be making intercepts of 9, 0 and 0, 6 on x-axis and y-axis respectively. I hope simple these are, very straightforward they are. You need not memorize or mug up anything. Some standard logical methods are supposed to be applied. Now, conversion of standard form to normal form is very interesting. Please remember some standard methods are to be applied. What are those standard methods? I'll directly share the modus operandi here, what is needed to be done. I'll directly share the approach. The rule. The rule says, first shift the constant term on the RHS, make it positive if it is not. So by multiplying it by, of course, minus 1. And then divide both the sides by coefficient of x square plus coefficient of y square inside an under root. What does it say? Let's say there is a straight line 2x plus 3y plus 7 is equal to 0. This is in the standard form. I want to convert it into normal form. Then how do I do it? First of all, take this 7 on the other side. So this will become 2x plus 3y is equal to minus 7. But the problem is it should not be negative. So I'll make it positive by multiplying it by minus 1 on both the sides. So what will I get? I'll get minus 2x minus 3y, I hope you can see it very clearly, is equal to 7. Any doubts, any confusion on that? Now divide both the sides by the under root of sum of square of this x and y coefficients. What do I mean by that? Minus 2 square is 4, minus 3 square is 9, 9 plus 4 is 13. So root 13 is what you divided by on both sides. So this will be minus 2 by root 13 times x. This is minus 3 by root 13 times y. And this is 7 by root 13. What does it mean? It is nothing but your normal form. What do I mean by normal form? What do I mean by normal form? The normal form means x cos alpha plus y sin alpha is equal to p. So this minus 2 by 13 is nothing but cos alpha here. This minus 3 by 13 is nothing but sin alpha here. And the perpendicular distance of this line from origin is 7 by under root 13. Did you understand this whole operation? Are you comfortable with this? I hope you will remember as a result and rule and you won't forget this. Now, moving ahead with the next part, which is called the distance form or the parametric form of a straight line. What does it mean? I'll simply try and tell you a very simple result that we know that y minus y1 upon x minus x1 is equal to tan theta, right? Can I write this tan theta as sin theta upon cos theta? Yes, we can. So if I write this tan theta as sin theta upon cos theta, I am coming up with a greater or a better conclusion now, which will help you a lot in understanding the parametric form of a straight line. How? Please have a look at that. X minus x1 I take there, sin theta I bring here. So it becomes y minus y1 upon sin theta is equal to x minus x1 upon cos theta. And let's say I put it equal to r. Y minus y1 upon sin theta is equal to r. R is a value I've assumed. I'll tell you what is the significance of R, but let's say R is a value, a just random value I've taken. So how do you define X? If I equate this with this, I'll say X is going to be R cos theta. X is going to be R cos theta plus X1, and Y is going to be R sin theta plus Y1. Now, what do I mean by that? Let me try and make you understand that result now. Basically, R is nothing but a distance. What do I mean by distance? When I'm trying to tell you the distance, it means, let's say there is a straight line. There is a straight line. And on this straight line, there is a point x1 comma y1. Of course, the angle this line makes with the positive x-axis is theta, which means the slope of this line, which is m, is given by tan theta. Now, what you need to understand is on this point, r distance away, there is a point lies. So there is a point lies r distance away. So when I say r distance away, a doubt must arise in your brain that, sir, r could be either upward or downward. So if r is upward, I'll take it as positively. If r is downward, I'll take it as negatively. So if there is a point r distance away on this line, which has a point x1 comma y1, r distance away from this point, there is a point, and that point lies on this line, which has a slope tan theta. So the coordinate of that point, is given by r cos theta plus x1 comma r sin theta plus y1. Will you remember that? Sir, but r could be here as well. The r distance can be measured in this direction as well. Yes. Let's say I'm saying 5 distance away. So if I'm going 5 distance upward, then I'll say plus 5. R's value I'll take as plus 5. And if I'm going 5 distance downward, then I'll take the value of r as minus 5. I hope you are making a great sense out of this part. There is no confusion on this parametric form of a straight line. You're able to bring this greater conclusion very clearly now. That's exactly what we have discussed. So I hope this is all what I have already told you. Now, this is the corollary. If I'm going 5 units away, I'll say plus r. If I'm going 5 units downward, I'll say minus r. That's exactly what I've already told you. So don't get confused with this part. Now let's talk about position of 2 points with respect to a given line. Please understand, this is even simpler. How? Let's say there is a straight line. There is a straight line. And there is a point A. There is a point A which has the coordinates x1 comma y1. The equation of the line is, let's say, the equation of the line is ax plus by plus c is equal to 0. There are 2 more points, let's say. So the point B is also there, which has the coordinates x2 comma y2. And there is another point, let's say C, which has the coordinates x3 comma y3. Did you get that part? Now, what I'm trying to make you understand is find the power of this point with respect to this line. So the power of A with respect to this line will be given by ax1 plus by1 plus c. Instead of x and y, just replace them by x1 and y1. That is the power of point A with respect to the line. Find the power of B with respect to this line. So power of B with respect to line will be given by ax2 plus by2 plus c, which means instead of x and y, replace them by x2 and y2. If both of the points lie on the same side of the line, then their powers will be of the same sign. They will be either both positive or both negative. So if both of them are positive or both of them are negative, then do you not agree that their product will be positive? Here, when I found the power of A with respect to that line, it was ax1 plus by1 plus c. Let's find the power of C with respect to that line. That will be ax3 plus by3 plus c. Now, whenever points lie on the opposite sides of a line, which means this is the line, on one side of the line, the point A lies, on the other side of the line, point C lies. They are lying on the opposite sides. In that case, the powers are of different sign, which means if this x1 and y1 has power positive, then this will be negative. Or if this x3 and y3 has the power positive, then this will be negative, which means the product of their powers will be negative. So on the basis of this only, we can say a lot about position of a point with respect to a line. Did you get that result? Did you understand that result? And if you have understood it very clearly, let's understand whatever we have discussed so far with this particular example. What does this question say? Let's have a look at that. A point on the straight line 3x plus 5y is equals to 15, which is equidistant from the coordinate axis. It is equidistant from the coordinate axis. Will lie only in which quadrant? That is what we need to answer. So there is a straight line. There is a straight line, right? If I could convert it into intercept form, it is going to be 3x by 15, which is x by 5, plus 5 by y 15, which is y by 3, is equal to 1, which means 5 comma 0 and 0 comma 3. So this is how the line will go. This is 5 comma 0 and this is 0 comma 3. I'm just drawing it for more clarity, right? I hope there is no confusion on that. Now, what are we told? That there is a point on this line. Let's take a point randomly here. Let's say this is the point P. It will have certain coordinates. Let's say its x coordinate is alpha. Its x coordinate is alpha. Can I say something about its y coordinate? Sir, what I'll say about its y coordinate will be a very simple result, that its y coordinate will be, see, from here, can I say 5y is 15 minus 3x? So can I not say that y will be 15 by 5, which is 3, minus 3 by 5x? So if I'm considering the x coordinate of P to be alpha, can I not say the y coordinate of P, which lies on this line, will be 3 minus 3 by 5 alpha? Let me just verify it once so that we don't commit any calculation based error. 5y is equals to 15 minus 3x. So y should be 15 by 5, which is 3 minus 3 by 5x. Great. What are we told? We are told that this point is equidistant from the coordinate axis. Can you help me with the distance of this point from the x-axis? Can you help me with the distance of this point from the y-axis? What are we told? That this point is equidistant from both the axes. We know that distance of this point from the x-axis will be its y-coordinate. Distance of this point from the y-axis will be its x-coordinate. So if this point is equidistant, then these coordinates should be equal, x-coordinate to y-coordinate. I hope you're understanding it. I hope there is no confusion on that. But this point could be in the fourth quadrant. This point could be in the second quadrant. This could be in the first quadrant. So the x and y coordinate could be negative, positive, whatever. So I need to take mod over them. So what I'll say is that alpha and 3 minus 3 by 5 alpha should be equated, but only after putting a mod sign over them. The best way to deal with mod is either you square both the sides or you remove both of the mod between, when equality is there, and place a plus minus sign on either of the sides. So let's say when I do that, so I'll say plus minus alpha is equal to 3 minus 3 by 5 alpha. Did you understand that? So I'll take plus alpha once and then minus alpha, and then I'll solve it. So when I take plus alpha, it becomes 3 minus 3 by 5 alpha. When I take minus alpha, it becomes minus alpha is equal to 3 minus 3 by 5 alpha. I hope there is no confusion or doubt or hesitation on that. How do I move further from this? Let me multiply both the sides by 5. So this is 5 alpha is equal to what? 15 minus 3 alpha. If I multiply both the sides by 5, it is minus 5 alpha is equal to 15 minus 3 alpha. Did you get that? I hope there is no confusion on that. 3 alpha when brought here, it becomes 8 alpha, which is equals to 15. And from here, I get alpha as 15 by 8. I hope there is no doubt on that. When I bring 3 alpha on the other side, minus 5 alpha plus 3 alpha is minus 2 alpha is equal to 15. So from here, I get alpha is equal to minus 15 by 2. I hope you are understanding it very clearly, that alpha will be either 15 by 8 or alpha will be either minus 15 by 2. When I locate 15 by 8, alpha is this point, right? So 15 by 8 will be in the first quadrant only. So when you take alpha as 15 by 8, I hope I will, without any hesitation, will say either it will be here or here. But 15 by 8 is less than 5. So 15 by 8 will be somewhere here only, which means it will be in the first quadrant. So my answer, first of all, here will be first quadrant. But I got another value of alpha, which is minus 15 by 2. Alpha, if it is minus 15 by 2, which means what? The x coordinate is negative. And if the x coordinate is negative, corresponding to that point lies on the second quadrant, in the second quadrant. So this point will lie in the second quadrant. So my answer will be either first quadrant or second quadrant or both. Did you understand this? So there will be 2 points, one point somewhere here, other point somewhere here, which will be equidistant from both the coordinate axes, which will be lying on this particular line. I hope there is no confusion on that. You have gotten a great clarity and you are understanding now how should you use these results and solve certain category of questions. Let's look at the other result. It says, let's say we are given a line. I'll simply give you a very straightforward example. Let's say we are given a line 2x plus 3y minus 7 is equal to 0. And we are told that find the equation of a line. Let's say there is a question, find the equation of a line. Let's say this is a line L. So find the equation of a line L1, which is parallel to L, and L1 passes through, let's say 0, 3. How will you do it? Please understand, don't put much efforts. What you need to understand is since L and L1 are parallel, their slopes must be same, which means 2x plus 3y will be there in that line as well. So I'll say that, let's say equation of L1 could be 2x plus 3y plus lambda is equal to 0. Because that will differ by the constant term only. Now what you need to understand is that since L1 passes through 0, 3, 0, 3 must satisfy this equation. So 0 plus 3 into 3 is 9 plus lambda is equal to 0. And from here we could crack that lambda is minus 9. On the basis of this you can say 2x plus 3y minus 9, 2x plus 3y minus 9 will be the equation of this straight line which is parallel to L and passes through 0, 3. Let us form one more category of question. Let's say I am asking you to find another line L2 which is perpendicular to L, and that line, let's say, passes through 3, 2. How will you write its equation? Now, previously the lines were parallel. When lines are perpendicular, just interchange their coefficients of x and y and replace one of the signs by a negative sign, which means this is positive, this is positive. Just make one of them to be negative. Just change one of the coefficients sign, either x or y. Do that. For example, let's say equation of the straight line is ax plus by plus c is equal to 0. And I wish to write the equation of a line which is perpendicular of it. So first of all, interchange the coefficients of x and y. So bx and ay. If both of them are positive, just change one of the coefficient sign, only one, which means let's say I keep this positive, this negative, plus of course some other constant is equal to 0. And they will give you a condition through which you can find this lambda. Did you understand this? So here again, when we are discussing this particular result, that a line perpendicular to this is needed to be drawn or written. Then how do you do it? I'll say 2x plus 3y. I'll swap these 2 and 3. So I'll write it as 3x and 2y. And I'll change one of the coefficient sign, only one. So let's keep 2x, 3x as it is. 2y I'll make negative. Plus let's say a constant is equal to 0. How do I find this constant? The line which is perpendicular to the given line is passing through 3, 2. So 3, 2 must satisfy this equation. What does it say? 3 into 3 is 9. 2 into 2 is 4. Plus mu is equal to 0. So this is 5 plus mu, which means mu should be minus 5. On the basis of this, equation of the line will be 3x minus 2y minus 5 is equal to 0. This is the line which is perpendicular to the given line and it passes through 3, 2. These are some very basic general observations which I'm giving you, which if you were to use, you will get a lot of great results. Now there comes another very important conclusion. Let's say there is a straight line. The equation of the line is given by ax plus by plus c is equals to 0. And there is a point x1, y1. There is a point x1, y1. And you are dropping a perpendicular from this point x1, y1 on this straight line. And then you are asked the distance or the length of this perpendicular dropped from this point on this line. It is given by power of this point with respect to this line, which is modulus over ax1 plus by1 plus c, divided by under root over a square plus b square. That's the distance formula between a point and a line, perpendicular distance. So from a point, if I'm dropping a perpendicular on a line, then the distance of that point from that line, perpendicular distance, is given by this formula. Will you remember this as a result? I hope you won't forget that. Now, moving ahead, how do we use this result? Where does it come from? Or how should we avail this? First of all, please understand, if I'm figuring out the distance of this line from the origin. Do you remember the normal form? Mod c upon under root a square plus b square. Do you remember that? So yes, 0 into a, 0 into b, that will become 0 plus mod c upon under root a square plus b square. That is the distance of a line from origin. That is exactly what we have created in the normal form as well. Do you remember that? Take the constant term on the other side, make it positive, divide both these sides by the under root of sum of squares of coefficients of x and y. That's exactly what is happening over here. I hope you're able to relate it with that same result only, right? Now, let us move ahead with the next question we are seeing right there in front of us. This question merges two concepts, quadratic with coordinate. How? Let's have a look at that. It says this equation has equal roots. So if an equation has equal roots, which means its discriminant must be 0, right? Now, apart from that, what we know is that the distance of this point, which point? K comma k by 2 from this line. So I think a very simple question. Can you believe this? JEE Mains has asked it in the last year. How? I'll simply do a start with this part. Let's simplify this as a result first. So what does it say? What does it say? It says x times x plus 2 times 12 minus k is equal to 2. Now, first of all, let's simplify this as a quadratic. So what I'll do is, I'll not do much with this 12 minus k. So I'll just multiply this x inside first. When you multiply this x inside, it leaves you with x squared plus 2x. And then I multiply this 12 minus k. So 12 minus k times x squared plus 2 times 12 minus k times x, I hope you're understanding it, minus 2 is equal to 0. Did you get this result? I repeat, the result is pretty simple. 12 minus k into x is 12 minus k times whole of x square into plus 12 minus k into 2 into x. So 2 into 12 minus k into x, and this 2 is brought here, and this is equal to 0. This is clearly a quadratic in x, but this quadratic has equal roots, which means its discriminant should be 0. Its discriminant should be 0 means what? B square, which is this 2 times 12 minus k whole square, that is b square, minus 4ac. What is a? A is 12 minus k. And what is c? C is 2. So I'm writing that 2 here. And when that 2 multiplies with this 4, it makes it 8. I hope that is understood by you all is equal to 0. Because the roots are equal. And if the roots are equal, I'll do one thing very clearly. I'll take this 12 minus k common. So when you take this 12 minus k common, what are you left with? I am now left with 2 square times 12 minus k. 2 square is 4. 2 square is 4, and I'm left with 12 minus k only from here. So that is 12 minus k plus of course 8 plus 8 is equal to 0. Did you get that part? I repeat, 12 minus k can be taken common. 2 square is 4 into 12 minus k plus 8. I hope there is no confusion on that. So when you put this 12 minus k equal to 0, you get the value of k as 12 without any hesitation or doubt. That is the value, one of the values of k. But from here, I think I can find other value of k as well. So let us try and get that value of k as well. So how do we get it? See, this factor should be 0, which means 4 times this plus 8 should be 0, which means 12 minus k. This is the value, one of the values of k, but then 12 minus k should be equal to minus 8 by 4, which is clearly nothing but what? Minus 2. Did you get that? So when k goes to other side, 12 plus 2 is 14. So the other value of k we receive is 14. But what's wrong with 12 or 14 or either of them? Let's say I try 12. So when I try 12 here, instead of k, 12 minus 12, 0 into anything, 0 is equal to 2. Well, that cannot be true. So with that, can I exclude this possibility? So I'm left with only one possibility, which is 14. So we have gotten the value of k, which is 14. So the point should be 14 comma 14 by 2, which is 14 comma 7. That's the point. What else do we have? The distance of that point from the line 3x plus 4y plus 5. So there is a line which is 3x plus 4y plus 5 is equal to 0. I hope that's the line we are dealing with. Yes. So we are dropping a perpendicular from here on this line, and we need to find the distance. The distance formula between a line and a point. How do we do that? Power of that point with respect to this line. So 14 into 3 plus 7 into 4 plus 5 is already there. I need to take a mod of it, but it is going to be positive anyway, so I need not put it. But for the sake of Keeping the formula clear here, I'll put a mod over here. Divided by under root over 3 square plus 4 square. I need not tell you what is that. You simplify this result and you will get the answer. My concern was to make you understand how do you eliminate that possibility of this k, and you should not take this k as 12. In rush, you may end up taking k as 12 when you say that 12 comma 6 is the point from where we need to find the distance, then it would have been wrong. So even with such silly or small or decent questions, you should be more cautious, because that is where JEE traps you. Did you get that part? Let us move ahead from here. Let's see what do we face next. The next is distance between two parallel lines. The formula is very simple. First of all, the lines should be parallel. Lines should be parallel means if the line is 2x plus y minus 3 is equal to 0 and the other line is 4x plus let's say 2y minus 7 is equals to 0, then of course both of the lines are parallel, but their coefficients should be same, which means if it is 4x plus 2y, I should take 2 common. Let's say instead of 7, I take 8 here. So I should take 2 common from here. So this line in a better form will be written as 2x plus y minus 4 is equals to 0. And then I'll use the distance formula between these two lines. So this version I won't use. I hope you are getting this conclusion first of all. Then how do you find the distance between two parallel lines? Please understand, it's a very simple formula. Take that difference between their constant terms. So minus 4 minus 3, the difference is 1, and take mod of it. So if it was minus 1, take a mod of it. Divided by under root over a square plus b square. So it will be under root over 2 square plus 1 square, which I need not say will be 5. So that's the distance between these two parallel lines. And this here is the formula. C1 minus C2 mod inside the mod divided by under root over a square plus b square. I hope you have gotten a great clarity on that front. Now, moving ahead from here, what do we have next? Concurrent lines. I'll simply tell you a standard formula. Let's say there are three lines. a1x plus b1y plus c1 is equal to 0. a2x plus b2y plus c2 is equal to 0. a3x plus b3y plus 3c3 is equal to 0. And if they are concurrent means if all of them are passing through one point, the way medians pass, they form centroid. The way the angle bisectors pass, they form incenter. The way perpendicular bisectors pass, they form circumcenter. The way altitudes pass, they form orthocenter. In the same fashion, if there are three lines and if they are concurrent, which means they are passing through one single point, they have the same common intersection point of intersection, then the determinant of the coefficients will be 0. This is the formula through which you can check or verify or validate if three lines are concurrent or not. This is something we have discussed while discussing the chapter determinants as well. Do you remember that? We had a discussion on this. So we had done questions there as well. So let's not bother about that. Now let's talk about family of lines. Please understand, let's say I'm given two straight lines. Let's say I am given two straight lines. So let's say this is one of these straight lines. This is the other straight line. So this straight line is given by a1x plus b1y plus c1 is equals to 0. The other straight line is given by a2x plus b2y plus c2 is equal to 0, right? Now, from their point of intersections, I hope you can see from their point of intersection, I can see infinite lines getting passed. Infinite lines can pass from the point of intersection of these two lines. I hope you are understanding what I'm trying to say here is that the set of these infinite lines is called family of lines passing through the intersection of this and this line. So let's say if the equation of this line is given by L1 is equal to 0, if the equation of this line is given by L2 is equal to 0, then family of these lines, all the lines combined in a clubbed manner are given by L1 plus lambda L2 is equal to 0. Now you keep trying different values of lambda. For different values of lambda, you'll keep getting different lines. That's what I'm trying to say here when I'm saying that it represents family of straight lines. That is exactly what is written over here. Now, what conclusions can be drawn based on that? That is exactly what I'll explain through a question. So I'm taking a question through which I'll make you understand how do you deal with questions based on family of lines. See, it says there is a line where lambda is a parameter. So when lambda as a parameter is visible there, I'll try to convert it into family of straight lines. How? I'll say 3 lambda x. So this is 3 lambda x plus 7 lambda y plus 2y minus 17 lambda minus 5 is equal to 0. Let me just cross check it once again. 3 lambda x plus 7 lambda y plus 2y minus 17 lambda minus 5. Now I'll keep the terms with lambda aside. So what are they? First of them is 3x. The second one is 7y. And the third one is minus 17. They are the terms with lambda. Now I'll keep the other terms aside, which are basically the terms without lambda, such as x plus 2y minus 5 is equal to 0. Are you not realizing this is clearly representing a family of straight lines? What do I mean by family of straight lines? If this is L1, then this is L2 and this is lambda. So this is L1 plus lambda L2 is equal to 0. What does it represent? It represents family of straight lines passing through the intersection of L1 and L2. Do you remember that? So all the infinite possible lines which can pass through this point, which is the point of intersection of line L1 and L2, all those infinite lines can be represented by this single equation only, where lambda keep on varying. So you keep trying different values of lambda and you'll keep getting different values of lines from here. But what is the question? The question is that all passing through a point P. So there are infinite lines which are passing through this point P. All right, that's great. Then what happens is one of these lines is farthest from the origin. One of these lines is farthest from the origin, and the distance of L from the point 3, 6 is D. The distance of that line, which line? Out of all these lines, which is farthest from the origin, distance of that line from 3, 6 is D, then you need to define D square. Okay, we'll talk about that. But as of now, can I find P? What is P? P is the intersection of these two lines. P is the intersection of these two lines. So lines are 3x plus 7y minus 17. Lines are 3x plus 7y minus 17 is equals to 0. I hope this was the line 3x plus 7y minus 17. The other line is x plus 2y minus 5. The other line is x plus 2y minus 5 is equal to 0. X plus 2y minus 5 is equal to 0. Now, how do we solve it? I hope it's easy and simple for us to find out the point of intersection. If I multiply this entire equation by minus 3, I'll get minus 3x. Here I'll get minus 6y. Here I'll get plus 15 is equal to 0. So this is what I've done here. If I add both of these equations, this and this are cancelled. 7y minus 6y is y. 15, 17 minus 2, that becomes 2. So y is 2. So if y is 2, I'll replace y as 2 here. So 2 into 2, 4. 4 minus 5 minus 1. Minus 1 goes to the other side, plus 1. So x becomes plus 1. So when y is 2, x is 1. So 1, 2 is the coordinate of P. Did you get that part? Did you understand that part? Now please understand, there is a line which is passing through P. There are actually infinite lines which are passing through P, but there is a line which is passing through P and it is farthest from origin. It is farthest from origin. So if it is farthest from origin, that is possible only when you take a line which is perpendicular to the line which I create by joining origin to this 1, 2. Now what I am saying is very simple and understandable if you know this very simple concept. What I'm trying to say here is, let me try and explain this particular result by this example. Let's say I have all these lines right there in front of me. Out of all these lines, let's say there is this origin somewhere here. Let's say this is origin. Now from origin, this will be this distance of this line. The perpendicular distance of this line from origin will be this. The perpendicular distance of this line from origin will be this. The perpendicular distance of this line from origin will be this. The perpendicular distance of this line from origin will be this. I hope you're understanding. I think I have included all the lines. But what you must understand is, there will be a line on which I will be dropping a perpendicular from origin. And that line will be passing through this point only, and that feet of the perpendicular will be this point only. Remember this as a fact, that this line will be the line which is farthest from origin. Are you able to digest the fact I'm trying to give you here? I'm trying to give you a very simple phenomena that let's say I fix a point. Let's say I fix a point. And from this point, of course, infinite lines can pass. And let's say I fix another point. And I say I am looking for one unique line out of these infinite lines which is farthest from this point. So the definition of that line, the identification of that line will be done on the basis of, on the grounds of the line which is farthest from this point will have the feet of the perpendicular drawn from this point on that line will be this point only. I hope you're able to understand this. So from here, if I'm concluding this particular result, that from 1 comma to infinite lines can pass. Out of those possible infinite lines, I'm looking for the line which is farthest from 0 comma 0. So the line which is farthest from 0 comma 0 will be that line which have its feet dropped from 0 comma 0, feet of the perpendicular dropped from 0 0 at 1 comma 2 only. Did you get that? Did you get that? I hope there is no confusion on that. So this is the line I'm looking forward to have. But what are we told? We are told that if the distance of L from the point 3 comma C, what do I mean by L? What was L? I hope you remember one of these lines, cell L is the farthest from origin. So the distance of L from this point 3 comma 6 is D. I repeat. So this is that line L. I hope you are not getting confused at all. So distance of this point L from 3 comma 6. So there is another point 3 comma 6. Of course, further ahead, of course, this will be the point 3 comma 6. So distance of this point, this line L from 3 comma 6 is needed to be drawn. Of course, it could be P, it could be some other value. Let me just simply write it like this, that 3 comma 6 is a point. From this point, I'm dropping a perpendicular. And I hope you know, from 3 comma 6, if a perpendicular is dropped, you know how to write, how to find the length of this particular, perpendicular. Do you remember that? If you don't remember that, I hope you must have this also with you, that if the distance of L from the point 3 comma 6 is D, I repeat, this line L is given. This line L is given to us. Let me just remove this so that it becomes more convenient for us. Now look at this point 0 comma 0 and 1 comma 2. I hope you're understanding this is what we have. Now, can you help me with 3 comma 6 now? Can you help me with 3 comma 6 now? So I'll say that there is this point Q for a while, which is 3 comma 6. Can you find, let's say this is O, right? Can you find the slope of OQ? Because I, as a teacher who has practiced such questions a lot, many times, can see a lot of things here. So if I find the slope of Q, I'll say 6 by 3, y2 minus y1 upon x2 minus x1, which is 2. If I were to ask you to find the slope of PO, I'll ask you the slope of PO, then you'll say 2 minus 0 upon 1 minus 0, which is 2 upon 1, which is also 2. So can I not say that the slope of QO and PO are same, which means these two lines, these 3 points must be collinear. And if these 3 points are collinear, what are we asked? That this is 90 degree, then I need not say that this will also be 90 degree. What am I asked? The perpendicular distance of this line from 3 comma 6. The feet of 3 comma 6 on this line is 1 comma 2 only. So what I need to find is D. What is D? The distance between 1 comma 2 and 3 comma 6. Did you get that? So if I am asked the value of D square, it will be, under root will get removed. I'll be writing 3 minus 1, 2 square plus 6 minus 2, that is 4 square. And I hope you have the answer 16 plus 4, which is 20. And that is given in the option A. Did you understand the whole explanation? Have you gotten a complete clarity on this question, which we have done with the concept of family of lines? With that, let us move ahead. Let us see few more concepts, few more learnings from this particular chapter. This is something which we have already discussed related to Circumcenter and Orthocenter. But yes, if you want to have clarity about Circumcenter, what I need to remember, I need to tell you is that simple phenomena. That's what is Circumcenter. It is the point of intersection of the perpendicular bisectors. So let's say I am given A, B and C. Please understand, what is the perpendicular bisector? This E will be the midpoint of AC. So if I have A and C, can I find the coordinates of E by section formula, midpoint formula? E will be the midpoint. Once you have found E, can you help me with the slope of AC? You can find the slope of AC. How? Because the slope of AC will be y3 minus y1 upon x3 minus x1. What is OE? We know that OE is perpendicular on AC. So if OE is perpendicular on AC, the slope of OE will be negative reciprocal of slope of AC, because their product should be -1 because these two lines are perpendicular. And we know that OE passes through a point E whose coordinates we know because E is the midpoint of AC. So can I not write the equation of OE, the perpendicular bisector? Why? Because I know the slope of the line OE. I know a point here E. So point slope form. Do you remember that y minus y1 upon x minus x1 is equals to m? The same logic I'll apply here on this f as well for a while, let's say. So f will be the midpoint of AB. And then I can find the slope of AB. The negative reciprocal of the slope of AB will be the slope of OF. So I'll have the slope of OF. I'll have the coordinate of F. With the help of this, I can write the equation of OF. So I have the equation of OE. I have the equation of OF. By finding the point of intersection of these two lines, will I not have the circumcenter? This is the third method of finding the circumcenter through slope formula. Did you get that? Let's move ahead. How do we find the orthocenter? That is even more easier, interesting even. I hope you remember, let's say we are dealing with the concept of orthocenter. Look at this part. Now, please understand, you just find the slope of OD and BC. How do we find slope of OD? Let's say O is the orthocenter, which I know is h comma k. Can you help me with the slope of BC? Yes, sir. Because BC, A, BC are the points we are given. If I'm given coordinates of A, if I'm given the coordinates of C, if I'm given coordinates of B, can I not write their slopes? For example, BC, the slope of AB and the slope of AC. I hope I can write them. I hope you are very much clear with that. Now, please understand, if I know their slopes, can I not know the slopes of OD, OE and OF? Because OD is perpendicular on BC. So if I know the slope of BC, I know the slope of OD. Did you get that? If I know the slope of AB, I know the slope of OF. That's exactly what we are trying to tell or say here. And now by taking any two equations, I again, out of these three, I can take any two and then I can again find the values of H and K. Did you get that part? So pairwise take any two and by solve them and then you can get the coordinates of orthocenter as well. I hope there is no confusion on that front. What we are trying to do here when we are asked to find the orthocenter, the way we have done questions on circumcenter. I hope you are completely understanding this result here. If you don't, I could have taken an example, but the numbers will be very difficult. It will become very confusing. Just follow these steps. You will see your answer coming right there in the next step. I hope we can skip this part. And if you are getting confused, I'll solve this part. Don't worry about that with some right data. Let me put some data here so that you understand it more clearly. For example, I'll just try and make you understand it more clearly, but of course, it's some vague data. I'll not be taking some correct data. Let's say this is point A, which is let's say x1 comma y1, right? This is point B, which is let's say x2 comma y2. And this is a point C, which is let's say x3 comma y3. Now, what I'll do is I'll drop an altitude from A on BC. I have dropped an altitude from A on BC. So let's say this is that altitude I have drawn from A to BC. Now what I know here is that this altitude has this feet D. Now can you help me with the slope of BC? Yes, because what is going to be the slope of BC? You can find out by y3 minus y2 upon x3 minus x2. So you know the slope of BC. Of course, let me drop one more altitude, let's say from B to this AC, and let's say this is that altitude, the other altitude. So this feet is basically, let's say E. So this is other altitude and they are intersecting at a point, let's call it H, which is the orthocenter, which we are trying to find out. Let's denote that by alpha comma beta. So we have the slope of BC. We can find it out. Can you find the slope of AD? Because on AD, AH lie. So can I find the slope of AD? Yes. I can find the slope of AD in terms of alpha and beta. Beta minus y1 upon alpha minus x1. So we know that these two lines are perpendicular, BC and AD. So the slope, the product of their slopes will be -1. So I'll get one equation in alpha beta. Similarly, if I take BE, the slope of BE and the slope of AC, then the product of their slopes will also be -1. So I'll get another equations in alpha beta. So with these two linear equations in alpha and beta, can I not find the solution here, the alpha and beta, which is the orthocenter? So that is again another method of finding the orthocenter through slope formula. So we need not remember any formula, just understand or remember this particular logic. Now, let us move ahead towards the next part here. Solve another question. Asked by JEE Maths in 2025, it says, ABC be the triangle such that equations of the line AB and AC be this and this. Okay. 3x minus x is equal to 2 and x plus y is equal to 2. Okay, great. And the points B and C lie on x-axis. If P is the orthocenter of the triangle ABC, then the area of the triangle PBC is equal to. Okay, let's begin with the data we have. ABC be the triangle such that equations of line AB and AC. So we are given two sides of this triangle, right? We are given two sides of this triangle. The two sides of this triangle are given by which two values, students, which two equations? So we have this triangle A, B and C. So AB is given by 3y minus x is equal to 2 and AC is given by x plus y is equal to 2, right? And the point B and C lie on the x-axis. That's the best part. So if B and C lie on the x-axis, would you not say their y coordinate will be 0? And the beauty here is, if I replace y by 0, I'll get x as -2. So I get the coordinates of B. If I replace y by 0 here, I'll get the coordinates here. That will be 2, 0. So that's the best part. I hope you are comfortably understanding what I have done so far. Third thing, if I want to figure out the coordinates of A, I need to solve these two equations. With these two, I can find the coordinates of A as well. What will be the coordinates of A? Add these two equations. X gets cancelled by x. 3y plus y is 4y. 4y is equals to 4, which means y is equals to 1. And when I replace y by 1, x is 2 minus 1, which is 1. So these are the points. Now what I need to find is P is the orthocenter of the triangle ABC. So now I need to find the orthocenter. As we have simply discussed, I'll give you the hint only. I am dropping a perpendicular here. That's a perpendicular. And I'll drop one more perpendicular. Let's say this is a perpendicular. I'll not be doing the calculation part here. I'll be simply giving you the hint here. Let's say this is the orthocenter here. Now, please understand, can you help me with the slope of BC here? Of course, let's say the orthocenter has the coordinates h, k. So we can find the slope of BC, which is x-axis only. So its slope will be 0. I hope there is no confusion on that. And if it is the x-axis, I hope you remember this is the x-axis only. So I need not even take it as h, k, because any intelligent student would say, sir, this is a line which is parallel to the y-axis, which is perpendicular to the x-axis. And if it is parallel to the y-axis, and on y-axis and y-coordinate, if its x-coordinate is 1 fixed, then the orthocenter, the x-coordinate of the orthocenter will be 1. I hope you're able to make this clear part very clearly here. I hope you are able to understand that if this is 1, this is the same line passing through A, which is the perpendicular line on the x-axis, which means it is parallel to the y-axis. And if it is passing through 1, 1 on x-axis, then this means its x-coordinate is always going to be 1 because it is parallel to the y-axis. Do you remember that? So the orthocenter will have its x-coordinate as 1. I hope there is no confusion on that. Now, by having this result in mind, you can say a lot about other results as well. Basically, I'm looking for the next coordinate, y coordinate of that orthocenter. How do I do that? Again, trust me, there are a lot of results. Which one? Let's say, will I not say that here, if I could find the equation of this line, if by some means I could find the equation of this line, let's call it D. So first of all, understand BD is what we know is perpendicular on AC. So the slope of AC, I hope you all must realize, the slope of AC is -1. I hope you can see it very clearly. If the slope of AC is -1, the slope of BD will be 1 because they are perpendicular. If they are perpendicular, the product of their slopes should be -1. Do you remember that? So I have the slope of BC. I know the point B. I know the coordinates of the point B. So equation of BC will be given by y minus y1 upon x minus x1 is equal to m, which is 1. I hope you remember it. But this line BD has this point H lying on it, which has X coordinate as 1. So if I replace X by 1 here, 1 plus 2 is 3, 3 into 1 is 3, so Y is 3 when X is 1, which means I have the coordinates of H as well. Now I won't solve it further because you have H now. You have H. Basically, it wasn't H, it was P as per the question. So you have P. And if you have P, I need not tell you how do you find the area of triangle PBC. PBC. Use the stair method or even other formulae. A lot of things are there. You know base. You know the base. The base is having the length 4. You know the height. The height is basically this, which is 3 only. I hope you're realizing this. So 4 into 3 is 12. Base into height, 12. Half of base into height is the area, which is half of 12. 6 is the answer. I kept on saying that I wouldn't solve, but I got carried away, and that's how we can solve a question based on orthocenter. Did you understand the whole solution? I hope you have brought a great clarity on this front, that how should you deal with questions based on orthocenter and circumcenter related to this particular concept. Now, let's say if I have a line which is equally inclined on two lines. So of course it will be, I hope it will be forming equal angles with these two lines. For example, there are two lines M1 and M2. There is third line which is equally inclined with these two lines. So this is the relation. I'll say that, let's say this line has slope M1, the other line has slope M2, and the line which I'm looking for is having slope M. And this line with slope M is equally inclined with the lines which are having slopes M1 and M2. So of course, the angle made by this line with the line which has slope M and the angle made by this line with the line which has slope M2 will be same. But it could be either acute or obtuse. So I need to use plus minus because I'll be removing that modulus sign. So to remove modulus sign from both the sides, from that tan theta angle between two lines, I'll be putting a plus minus sign. And when you solve this, by solving this either quadratic or plus minus sign, you'll get two values of M. So there are two possible straight lines which can be equally inclined on the two given lines. This is how we will be solving questions based on line which are equally inclined on two lines. Now let's talk about angle bisectors. From that previous concept only, we'll talk about that. So let's say these are the two straight lines. These are the two straight lines. First one is L1 is equal to 0. Second one is L2 is equal to 0. Now let's say I am asked to write the equation of angle bisector. Now what is the locus of angle bisector? I'll say on angle bisector, if I choose any point, on the angle bisector, I'll say from that point, the perpendicular distances of these lines whose angle bisector we are trying to figure out will be same. Any point you take on this angle bisector and you draw perpendiculars, these perpendiculars will be of same length. By using this concept of perpendicular distance, we can write the equation of angle bisectors. I hope you have understood it very clearly. We can move ahead from here. Now, when I move ahead from here, I'll directly come to the part where we will talk about foot of the perpendicular from a point. That's more interesting. I'll try and tell you this particular result with a simple example. Let's say there is a straight line which is given by x plus y plus 7 is equal to 0. There is this point, let's say 2, 3. From 2, 3, I have dropped a perpendicular on this line and we are asking you to find the foot of that perpendicular. And let's say we are asked to write the image of this point 2, 3 with respect to this line. How do we do that? Always remember, the funda is pretty simple. There is a standard formula. Although there is a logical approach as well. The logical approach is this, that let's say this is a line. So I can assume a point on this line which will satisfy the equation of the line. And one more thing, since it is perpendicular on this line, slope of this 2, 3 and alpha, beta, the line segment, will be negative reciprocal of slope of this line. By using these equations, I can find the coordinates of feet alpha, beta. If I'm asked the mirror image of 2, 3 with respect to this line, which is let's say h, k, then I'll say alpha, beta we have been able to find. So alpha, beta will be the midpoint of h, k in 2, 3. So by using that midpoint theorem, I can find h, k as well. But even if you don't want to do all this, there is a standard formula. Let's learn that. The formula says, let's say if I want to figure out alpha, beta. So I'll say alpha minus 2 upon coefficient of x, which is 1, should be equal to beta minus 3 upon coefficient of y, which is 1, should be equal to negative of power of 2 comma 3 with respect to this line, which is 2 plus 3 plus 7 divided by a square plus b square, which are coefficients of x and y. So 1 square plus 1 square. Don't put an under root over here. In distance formula, we do that. But when finding the feet of the perpendicular or mirror image of a point with respect to a line, don't do that. And now by taking them one by one, what do I mean by that? Let me simplify this result first of all. 7 plus 3, 10 plus 2, 12. 12 upon 2 is clearly 6. So this is minus 6. So from here, if I compare this result with this, we know that alpha minus 2 by 1 is minus 6. So alpha will be minus 6 plus 2. Minus 6 plus 2 will be minus 4. So this will be minus 4. Similarly, what about beta? Beta minus 3 upon 1 is minus 6. So beta minus 3 is minus 6. So beta should be minus 3 plus 6, which is minus 3. So this is the feet of this point on this line when a perpendicular is dropped. What about the mirror image? For mirror image, the formula is even simpler. You will say h minus 2 divided by coefficient of x is equal to k minus 3 divided by coefficient of y, which is 1, should be equal to, in this formula, when we were dealing with this concept of feet of the perpendicular, when you deal with the mirror image, we say minus 2. So instead of this minus 1, I'll put a minus 2 here. Minus 2 times power of 2 comma 3 with respect to this line, which is 2 plus 3 plus 7 divided by 1 square plus 1 square, which is basically 2. And when you solve this, you will get h comma k as well. I hope there is no confusion on that and you have understood it very much clearly. Right, let's move ahead. So by simply simplifying this, you can get this value as well. Or even if this is the midpoint of this and this, you can get the result from here as well. I hope there is no confusion on that. So I think you have gotten a great clarity that how to find the feet of the perpendicular dropped from a point on a line and also the mirror image. Right, now with that, when I proceed further, what do we have next? This is exactly what we have discussed. The formula which will be giving you in the notes. So don't worry about that. You will receive all these things. Don't bother about that. These are the results which we have already discussed. And that's how we end this one shot of the chapter straight lines. So I think we have given a great clarity about coordinate system, Cartesian system, and straight lines, different forms, how to deal with them with a lot of previous year's questions. And all of this is provided to you in our Elevate JEE Crash Course program at absolutely no cost with complete, comprehensive, thorough manner, in a comprehensive and thorough manner. Along with this video, we are also giving you these notes, handwritten notes. This entire notes will be given to you at no cost. And the DPPs will also be provided to you for your revision, which you can practice in the real-time environment. The environment which you'll be receiving in the JEE examination hall, the online format only, at absolutely no cost. Please understand the significance of this and avail this opportunity. With that, I think this is sufficient for the day. Let's meet in the next video. Thank you so much. You have been a great audience.